Hello, everyone. Welcome to the Bread of Life channel. Tonight, I'm going to be talking about the evidence for and against the Big Bang. And just to make it clear to everyone, and most who are here probably know this channel pretty well, but this is primarily a channel for Christian evangelism. So, what is a Christian who's primarily concerned about Christian evangelism? Why am I talking about the Big Bang? Well, you know, um, I've always been skeptical about the Big Bang, but I never really looked into it until maybe about 6 months ago. I can't exactly remember how long it was, but I asked a friend. Most of you know him, Sal Cordova, my creation advisor, to send me some information about the Big Bang. And when I read this information, I was completely shocked. I was shocked at how I had never heard any of this. And so I want to share that with you guys tonight. And, I just want to say, look, my purpose here, I do hope to make some more skeptics to the Big Bang. Why? Because I have an interest in people believing the truth. Now, there's a lot of Christians who believe in the Big Bang who are really not going to like me even talking about this because they think I'm making Christianity look bad or Christians look bad. Hey, let's face it, I'm not in the cool Christian club, okay? I don't get to hang out with William Lane Craig because he thinks there's Big Bang, and all the Christian cool kids. I don't fit in their group because I won't get on board with the Big Bang and other certain beliefs that a lot of Christians are on board with. Okay, so and that's fine. But let me make it clear: if you're a Christian and you believe in the Big Bang, I have no problem with that because you have a supernatural being who is able to make things like a Big Bang happen. Okay, fine. You believe in the Big Bang. It was miraculous. Cool. But the reason that I want to talk about the Big Bang and hopefully cause people to be more skeptical about it is because this is being promoted as it's supposed to be a theory of how things came about by natural processes. And you should understand that the very basis of this theory is not resting on physics that we can currently explain. Okay. And people are going to, if you want to argue with me about that, then let me just read to you. Okay. Because let's talk about what is the Big Bang proposing. Well, it's proposing that everything that we see in this orderly universe, all the planets, all the galaxies, everything that currently exists has been expanding and it used to be in a singularity, a tiny, very dense something that somehow I'm afraid to even use these words because people correct my words. I'm a layman doing this, and I am going to bring you the science from people who actually can do a better job explaining. But it's supposedly everything that ever that is part of this universe was once in a singularity. Now, do we have a physical law, something that we can observe to say how this could happen? The answer is no. If you want to argue with that, let me just read the simple what Wikipedia has to say on this. And if you don't like what Wikipedia has to say, you can go in and change it. But even beyond, I like Wikipedia's summary, but I did look beyond Wikipedia and I found that this is true. So if you want to argue with it, that's fine. But just listen to this. It says, okay, this is talking about the idea of a gravitational singularity, a space-time singularity, okay, which is what the proposal of the Big Bang Theory is. It says, Gravitational singularities exist at a junction between general relativity and quantum mechanics. Therefore, the properties of the singularity cannot be described without an established theory of quantum gravity. Trying to find a complete and precise definition of singularities in the theory of general relativity, the current best theory of gravity, remains a difficult problem. A singularity in general relativity. Okay, this is now it's getting and into a deeper description that we don't need to go into. But the point is that right now, the idea of this universe starting out as a singularity is not something that comports with physics and quantum mechanics as we know it. So if you are believing in the Big Bang, you're believing in something that is at its core something that we cannot explain scientifically. So it's a it's an unknown. It's an unknown. So you're choosing to believe it. Okay. Now, this is what this is the some of the stuff that I read at the beginning when I started looking into the Big Bang. And I realized how seriously problematic this theory is. And I want to show you guys. This is an open letter, and everything I put up on the screen tonight is something that you can go and read yourself. I've listed all the references, but this is an open letter on Cosmology. This is written by Eric Lerner, and it is signed by a bunch of people. Okay, these are astrophysicists. These are people working in this field, including 3 of Sal's professors. I don't remember if it was at Johns Hopkins or where it was, but basically 3 of Sal's professors signed this. Okay, and so this is a few of the brave souls who are working in this field who actually stepped out and acknowledged the problems with this. And that is very hard to do right now. It can be a career ruiner. So these are very brave souls. So, if right now, I think the biggest reason that probably most of you believe the Big Bang is just because it's what people have told you. It's the experts. This is what they have said. But here are some experts who are saying, no, this is problematic. And so let's just read some of this. It says, the Big Bang today relies on a growing number of hypothetical entities. Things that we have never observed, inflation, dark matter, and dark energy are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would, at the least, raise serious questions about the validity of the underlying theory. But the Big Bang theory can't survive without these fudge factors. Without the hypothetical inflation field, the Big Bang does not predict the smooth isotropic cosmic background radiation that is observed, because there would be no way for parts of the universe that are now more than a few degrees away in the sky to come to the same temperature and thus emit the same amount of microwave radiation. Without some kind of dark matter, unlike any that we have observed on Earth, despite 20 years of experiments, the Big Bang theory makes contradictory predictions for the density of matter in the universe. Inflation requires a density 20 times larger than that implied by Big Bang nucleosynthesis, the theory's explanation of the origin of light elements. And without dark energy, the theory predicts that the universe is only about 8 billion years old, which is billions of years younger than the age of many stars in our galaxy. What is more, the Big Bang theory can boast of no quantitative predictions that have subsequently been validated by observation. The successes claimed by the theory's supporters consist of its ability to retrospectively fit observations with a steadily increasing array of adjustable parameters, just as the old Earth-centered cosmology of Ptolemy needed layer upon layer of epicycles. Okay, you can read the rest of this, and the rest of it is great too. But so this is, like I said, it's signed by people working in this field, respected people in the field, and it's showing some of the problems. Now, another excellent paper that was written actually, I believe in 2004, 2006, that is still valid right now, is a paper written by Michael Disney. And I'm gonna, let's see if I can change over. I want to share my screen again, but on this other paper. So, okay, now Michael Disney is an astrophysicist, and he wrote this article entitled, hold on, sorry, Modern Cosmology, Science or Folktale? Look at the strong wording here, guys. And this is what this article is about. In a survey for non-astrophysicists, we compare the number of independent measurements which support the Big Bang cosmology with the number of auxiliary hypotheses, such as dark matter, dark energy, and inflation, and their associated free parameters needed to shore it up. We find that such parameters still outnumber the relevant observations, with no real sign of an improving trend over time. This was written 20 years ago nearly, and it is still valid today. It is still true. In fact, it's even more true than ever with the recent discoveries that have been made. It says this: non-cosmologists are thus entitled to be skeptical of such a weakly supported superstructure, which is currently composed of 5 separate theories piled on top of one another. So what are those separate theories? He goes through this talking about the different levels, that these are actually different theories. And the ground level of the theory of the Big Bang is the expansion of the universe. Okay. And so that's the one, that's the ground level, actually has some observational support. Okay. But then there are other theories on top of that. I should have kept that pulled up, but I think I have them written down here. But there are other on top of that they build upon each other. But there's, this idea of inflation. You need inflation for, and I'll just read it from the thing. You need inflation. What you need inflation for to make this work. That's the next level. You have to have dark matter. You have to have dark energy. You have to have dark matter for galaxy formation. And so without galaxy formation, you don't have a theory of how the universe began, because you have to get galaxies. So I highly recommend anyone, any layperson, if I can understand that paper by Michael Disney that lays out the problem so clearly, you can understand it. If you're willing to take an hour of your time to read that paper by Michael Disney that I still had pulled up, it will help you so much to understand how much of this is resting on theoretical ideas rather than observations. Only the first thing, the ground floor in this theory, actually has observation to support it. And the rest of it is completely unsupported. The other 4 levels are completely and totally unsupported by observational evidence. So, and a final quote from Michael Disney that's also in that paper. He says this: in a robust astrophysical field, such as stellar structure, there will be many more confirmatory observations than free parameters. In contemporary cosmology, this turns out not to be the case. Remember, this is an astrophysicist talking. This is not this is not Rebekah. This is not somebody who doesn't know the field. He's talking about the problem in his field. Indeed, as we shall see, the number of free parameters probably exceeds the number of relevant independent measurements, as it is done throughout history, with no sign of convergence between the two. He says this: just because professionals cling to such a flimsy theory, this need not discourage the rest of us from being a good deal more detached. Okay, so he is saying, look, even if the professionals are willing to cling to this flimsy theory, you have a good reason not to. And so now let's talk about the good reasons not to and look at some other papers, because what I want to challenge even, and we can talk about how dark matter has not been observed. It absolutely has not. Now, we see strange gravitational things happening in galaxies, but so we have something that we need to understand. But what we don't have is an observation of this hypothetical entity, dark matter, and we have spent millions of dollars building giant machines to try and observe it. And I linked an article to a machine that was built to try to observe dark matter, and there has been no observational. There's also been studies that have been done that compared different galaxies that are close together to try to see if dark matter was affecting their pull on each other. And, this is, so far, we've come up with nothing for dark matter. So it is true that we see we don't understand the properties of how galaxies work, but that doesn't give us a reason to just continue to cling on and have a theory that's entirely dependent on this thing that we've never observed. Now, is there a good reason? Okay, the two pieces of evidence that are given there's two pieces of evidence used to support the Big Bang Theory. Okay. The two pieces of evidence are, number one, the Redshift. That was discovered in 1921. And it's really the reason that the Big Bang Theory is even around. So the Redshift, it looks like when we look out at the universe around us, the stars, the galaxies, everything, what it looks like is that they are moving away from us, because the transmissions that we are receiving are red shifted, red light spectrum, which seems to be that they are going away. Now, this is the observational evidence that the Big Bang is founded on. So one of them. So does redshift necessarily mean that these things are indeed expanding, or that space is expanding? No, it does not. Okay. And I'm going to show you papers in a minute that show other possible explanations and things that we've observed that show that redshift does not correspond to an expansion of the universe. Okay, that there is probably another explanation for it. And then the second thing that's a piece of evidence for the Big Bang is the cosmic background radiation. So that is just this radiation that that seems to be pretty smooth, that is we can detect all around us. Now, this is predicted on the Big Bang model, and it was predicted before it was discovered. And it was discovered by some people who weren't even trying to discover this as related to cosmology. So this is a successful prediction for the Big Bang model. It's good. However, is the cosmic background radiation is the only explanation for that, that the universe was once a singularity. Is the Big Bang Theory the only thing that can explain cosmic background radiation? I don't think so. Now, I don't know. There's a lot of things that may be causing radiation in the universe. To me, that's a weak thing to rest an entire model for the origin of the universe on. But so I'm really going to focus right now on the evidence that the redshift is not expansion. It doesn't mean that that the universe is expanding. And so I'm going to pull up some slides here. So this is a paper that was published in July 2021. And right now, I don't have the whole paper pulled up here, but I do have the link in the description. And later on, I may have a special guest come on to come and explain more about this if I don't do a good job explaining. And by the way, I am a layperson at this. I've probably spent maybe a total of like 30 hours reading about this. So I don't know that much. And I don't understand everything that I read in these papers. And if there's any astrophysicist out there that would like to come on and correct me about anything that I'm saying, I'm very open to that. And I would be happy to have someone come on and respond to some of the scientists who have given me the information against the Big Bang. So I welcome that. So if you're an astrophysicist or someone in a field related to this and you have special information, then please get in contact with me. And, you know, if I fail to explain this well, I just challenge you to read the actual articles for yourself, because I may fail in my explanation, but that doesn't take away from the fact that these papers exist. The evidence exists. Okay. So deal with the evidence, not my poor explanation. So this is a paper from the Journal of High Energy Physics that talks about the redshift that occurred when Pioneer 6 entered the sun's corona. So Pioneer 6 spacecraft that was out there, when it entered the sun's corona, the transmission that came back from it was redshifted. Now, that's not what we would expect, because, you know, this is, it shouldn't be giving us this. It's not, this was an unexpected result. So that gives us one clue that the redshift that we may be experiencing from stars and planets or stars and galaxies, supernova, may not be due to them moving rapidly away from us. Okay. And I think I underlined some parts of this. Let me see. So let me see if I can read this. So the calculation of the redshift can be traced back to the interactions between the radio signal and the electrons of the solar corona alone. So it wasn't the redshift due to this space probe was not about it moving away from us. It was traced back to the interaction of the electrons with the solar corona. And so the interaction with plasma may be the actual explanation for why we see everything redshifted. And if you guys stick around long enough, I will be going into more detail about some of our observations with JWST that are totally blowing away the idea of redshift meaning expansion. So, okay, this is actually the paper from the original article that came out about Pioneer 6. The other one was from 2021. This is from 1974. So, okay, and it basically says the same type of thing: an anomalous redshift added to the normal linear redshift due to the spacecraft. I'm blocked from seeing the rest of this. I think I have it here, but basically it is again describing why we got this redshift coming from that probe. Now, another paper that shows that, hey, maybe maybe the universe really isn't expanding. Maybe it's actually static. Well, came from this paper published in 2019. And this is by David Crawford. It was published at the Astronomical Society of Australia. And let me see if I think I printed this one out for myself. But basically, this one is talking about the problem of time dilation. Now, the observations that they did on supernova. So basically, sometimes we are using supernova to do like the light from supernova to like calculate distances and things like that. Now, according to general relativity, right? Most people are familiar with this, the idea that time slows down for those who are traveling more rapidly. And so if we're looking out at distances, things that are traveling very fast away from us, we expect there to be an effect that time has on those things that we should look out, and we should see an age that corresponds, that we should see some effect of the difference with regard to the time dilation. So this was an article that explains how they looked for this, right? They looked for some observation that could show, and I'll just read what it says here. In supernova, light curves shows that their widths relative to a standard template have a power law exponent as a function, blah, 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 which is consistent with no time dilation and inconsistent with standard time dilation. In addition, it is shown that the standard method for calibrating the type 1A IA supernova light curves, 1A, I don't know if it's 1A or IA, light curves is flawed, which explains why this lack of time dilation has not been previously observed. Now, so he says here it shows that the peak absolute magnitude is independent of redshift if a static universe cosmology, curvature cosmology, is used to provide the distance moduli. And I think I have one more quote from this. So this is in their conclusions. Oh yeah, and there's something about gamma ray bursts, and I'm going to have someone more technical explain this. But in addition to the duration, gamma ray bursts are completely consistent with the static universe. So the things that they are observing in these observations of the supernova are consistent with the static universe, inconsistent with an expanding universe where time dilation effects should be seen. And okay, I have to fully admit, I don't completely understand this paper, but I have someone, a special guest, who can come on and explain that after I get done with my main presentation. So we are going to come back to that. But I want to go on because I want to make sure that before we get too deep in one topic, that I just give a good overview of the problems. So going on, this is another paper. This is, I don't think this has been published in a peer-reviewed journal right now. It's kind of one of those that's like in pre-review or whatever, but it's called A Different Perspective on Blue Sky Theory of Single Photon Scattering on Bound and Free Electrons. So this is another test that was done that showed the effect of electrons and what happened. And if you just read this one line here, it says the new theoretical model predicts that the redshift of photon wavelength resulting from such interactions. In particular, it provides an explanation for the blue color of the sky and an alternate explanation to cosmological redshift. Okay, so it is, we haven't made anything conclusive yet about what is causing redshift. For many years, the primary thing that has been thought to cause redshift is the expansion of the universe. But now we're seeing some of these things come out where redshift doesn't always seem to correspond to that, and that this could actually be electrons, plasma, scattering of light, different things that may be causing this thing that we're observing as redshift. And we have some recent observations that make that even more probable. So here is another one. Okay. Now I'm going to try to explain this one because Sal explained this to me, and I'm going to try to explain it. But if I don't do a good job, he's going to come on and explain it. So this one is time dilation and quasar variability. So basically, we use quasars in galaxies because they send out bursts of light, and we can kind of track, like, okay, it should burst at this time. They kind of have like a set way of bursting, and we kind of track, and we can use that to like measure different things. So but basically the idea here was that, hey, if we're looking out at these very distant places and they're traveling away from us very fast, then hey, wait a minute, we should see the effects of that in the time period in between the bursts. We should see a difference in the time period. And so what was seen in this study is that no, actually, we don't see the effects of time dilation. We don't see that with the quasars. So that's really strange. So if this redshift really means they're expanding and moving away from us so quickly, then why are we still observing the quasars pulsing at a rate that is consistent with non-expansion? So again, if I am not doing a good job explaining this, I have someone who is going to come on later and explain. Okay, someone more qualified than me. But for now, let's talk about some of our recent observations in the sky that with the telescopes that have kind of shown some of the problems of this. And actually, this goes back farther than JWST. Now, this was a paper that was published by Eric Lerner, and he's the one who wrote that letter that so many people signed. Okay, so this was published in the Monthly Notices of Royal Astronomical Society, volume 477, July 2018. Okay, now In this paper, he talks about our observations contradict galaxy. Okay, it's called Observations Contradict Galaxy Size and Surface Brightness Predictions that are based on the expanding universe hypothesis. Now, I really do recommend going and looking at this whole paper, but I don't have everything pulled up here, but I'm just going to try to summarize it. But you are welcome to look at it yourself. But basically, Lerner, he didn't buy into this whole expanding universe thing, and he made predictions. And they looked at the Hubble telescope and the Hubble telescope predictions of what galaxies would look like, what size they would be, and blah, 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 blah. And all the properties that were predicted for the Hubble telescope. And then what actually came out, what information came out with the Hubble telescope. Now, so there was already a problem with the Hubble telescope predictions with the sizes of the galaxies getting smaller and smaller, like getting to impossibly small sizes. But now even it got worse when we got the JWST results. Well, as we're getting the JWST results and some of the very distant galaxies that we're observing. Okay, so many problems with those galaxies. Okay, number one, they're not even supposed to be there because we're looking out at distances like 330 million years after the Big Bang. Now, we're not supposed to be seeing mature galaxies out at that distance. Why? Because they weren't supposed to form yet. Okay, according to the Big Bang model, there was no time for them to form yet. And then, so the Big Bang model predicted not until like after 1 billion years would there be galaxies like this. And we're seeing galaxies that are out as far as 330 million years after the Big Bang. So the fact that they're there, that's a problem. The fact that they're mature, that's also a problem, because what the Big Bang predicted is that we would see, and later, I mean, not this far, but we would see small, like kind of nebulous galaxies that weren't very structured, like they weren't as structured, and no disk galaxies, no elliptical galaxies, not that kind of thing, because those would take much longer. In fact, it was said that elliptical galaxies are supposed to take 7 to 10 billion years to form. So elliptical galaxies are supposed to be really old. Well, guess what? We have elliptical galaxies that are out at those reaches of the universe where they're not supposed to be there. They shouldn't be there. So that's basically, if you see it there and it was supposed to take billions of years to form, that's a major problem for your theory. The other thing that there was supposed to be, we were supposed to see a bunch of galaxy collisions, because the whole idea was they had to come up with a way to get big galaxies. And so they said, well, we think these like galaxies sort of collided, and early galaxies collided many times, like 20 times, and then finally came up with these big galaxies. And that's just not what we're seeing. So that's another failed prediction of the Big Bang. And then on top of that, in these recent ones from JWST, we're seeing things at very far redshift, and the galaxies are getting ridiculous in their size for their volume, and like, so you have this is from Eric Lerner, by the way, and I have a link to his series that he did on YouTube, The Big Bang Never Happened. He wrote a book called The Big Bang Never Happened. And so anyway, a lot of people have tried to, they call him a quack and they try to discredit him. But you know, what's interesting is I tried to find people who would discredit his science, and I could not find anyone who would contradict what he's saying here about the galaxies. I couldn't find anyone who would contradict this. And so what people have done is make a lot of attacks on him, but nobody's actually addressing these scientific issues that he's bringing up. So if somebody wants to challenge him, challenge his credentials, well, how about challenging his science? How about saying how what he says here is wrong? Because as best I could, I looked up to see if what he's saying about these galaxies is true, and I confirmed it from the research that was coming out from the scientists looking at the JWST themselves. Now, I had to parse through their articles because some of it's kind of obfuscated. Honestly, but the data is there. And so they're not saying this in plain terms like Eric Lerner is, but the data that he is saying is right. And so he says he shows that these galaxies some of them are impossibly small, some of them are impossibly bright. And we're looking out at these galaxies that look like galaxies that we're familiar with, but they're not corresponding with what we know about galaxies' mass and things like that. Why is it a problem? It's because of the expansion calculations that we're putting in there, because we're calculating as if the Big Bang is true. We're calculating as if expansion is happening. And so because of that, we're finding all these like impossibly small galaxies. Now, if you just ignore, if you take away the idea of expansion and you just calculate the size of these, if you just calculate redshift as a correlation with distance, just normal, like that, redshift, it is indicative of distance, but it's just correlated with normal distance, not expanding, then all of those galaxies that we're observing are actually very similar to the galaxies that we observe nearby. So if we just ignore the expansion stuff, then we have no problem with these galaxies that we're seeing, with the sizes and volume and brightness and everything. But if you keep putting in this expansion stuff, then you have a major cosmological problem. And it's not just Eric Lerner saying it. It is the scientists themselves. And I believe I put this in here. Yeah. So that one, okay. So this is from a paper that came out with it, just basically just a paper filled with data coming out about the JWST. But so it says these properties are consistent, that talking about these galaxies that are out there, consistent with expectations for galaxy formation in lambda cold dark matter cosmologies at these redshifts. The galaxies have median star formation rates comparable to the Milky Way, despite them being 100 times less massive. Wow, that is really weird. So, and then, in another one we've got, and this is the famous one that people talk about. Oh my gosh, I forgot to put it in here. Well, anyway, you can look it up because it is there. And I have it right here. It's the panic at the disks. Now, I've heard a lot of people say, what panic? What panic? They were just making a joke. They were making a joke. No, the title might have been a little bit of a joke. It was a play on the Panic at the Disco. Okay, but why did they use panic? Because this is a problem. The panic at the disks. This is the problem. They're having a problem with the galaxy structures, and they talk about it in here. And so they're admitting very cautiously, because they have to be cautious because they want to keep their job. But they're admitting that things are not right here. The formation of normal galaxy structures was, okay, these early JWST results suggest that the formation of normal galaxy structure was much earlier than previously thought. Thank you for admitting that. But guess what? That doesn't correspond with your theory. In fact, it's a major problem for your theory. I think it's even keeping some scientists up late at night wondering if everything that they've believed is wrong, as some of them have quoted. And then, so going on, this was the galaxy, okay, blah, 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 population 10 times as high as what was previously thought to be the case with Hubble Space Telescope observations. That is, this epoch is surprisingly full of disk galaxies. Okay, they weren't expecting this, guys. And it's not like, oh, what a lovely revelation. Yeah, it's lovely for science. It is really, really lovely for science, but it's not really lovely for the Big Bang Theory. It's really ugly for the Big Bang Theory. It's a huge problem for the Big Bang Theory. And some may be saying, well, it's a problem, but we'll figure it out. We'll figure it out. Well, okay, I'm glad you're planning to figure it out, but what are you going to have to do to the Big Bang Theory now? Because you've already added, to make the theory sustainable, you've already added dark energy, dark matter, seeds, inflation. How many more things are you going to have to add to keep this afloat? When will you finally say, wait a minute, maybe the whole theory's wrong. Maybe we should just start from scratch. Let's just start from scratch and just use scientific observations and then come up with something just based on our observations, not just two observations, redshift and cosmic background radiation, but let's consider all the observations we're making. So another thing, okay, not as highly clumpy and asymmetrical as once thought, yes. And then they say this study is the first examination of the problem of distant galaxy morphology with JWST, specifically the formation of galaxy structure at redshift greater than 3. So there is a problem, despite the hand waving of, oh, no problem. We don't have problem. Jedi mind trick. Problem? I don't see any problem. Yes, there is a problem. And so I hope those who are listening, I really do hope you will be a little bit more skeptical. You know, I have to tell you, my husband used to be very into astronomy, cosmology. He was an atheist. And it was actually cosmology, the absolute like joke that it is, that caused him to start first considering that maybe God exists, because there would be something that comes out every week. Oh, actually, okay, we're assuring you that this is correct. This is correct. And then the next week, now it's not correct. And it's like, okay, wait a minute. You were promising me that this was correct, and now it's not correct. Okay. So for all of the assurances, all I'm saying is, you know, if you're going to believe something, you should probably have more than just assurances from experts. So how about looking at the data? And so I think I think I've done enough. I think I might want, I'm just going to look over my notes and see if there's anything that I failed to say, because, oh yeah, I also want to say that, you know, we're supposedly trying to calculate the expansion rate, right? If the universe is expanding, we should be able to calculate how fast it's expanding. Hey, we can look around at stuff. We should be able to, you know, measure things and see how fast it's expanding. And we're trying to do that. But guess what? We have several different methods of doing that, and they don't match up. They don't match each other. You know, when we're using supernova, Cephid variable star, the calculation for the expansion rate comes out one way. And then when we use the cosmic background radiation, then it comes out a different way. So we can't, there's no calculated expansion rate. And that is another problem. There's many problems for this, but some may say, well, but we know it's expanding. Well, we have some observational evidence that suggests it's expanding. We have other observational evidence that suggests it's not expanding. Okay, so I've talked about the problem of dwarf galaxies, but I haven't talked about the problem of large structures. That was another failed Big Bang prediction. Big Bang predicted that nothing could be farther than across more than like 1 billion light years. Now we have things that we've discovered that are like 3 billion light years across, and we have no idea how those could have formed. That is another problem. So I think that's enough. But I'm gonna now let have Sal come on and explain in more depth the papers that I mentioned that talk about the redshift and anything else he wants to say. So welcome, Sal. Thank you for
welcome. Welcome, my fellow nerd. That was awesome, nerdy torture stuff. I love it. It was so nice to see you long-winded. She gives me such a bad time. She said, Sal, be more succinct. And today, Rebekah, this was just great to just see you have a 51-minute monologue. I'm proud of you.
Thank you. Okay, I'm gonna be looking at the comments now. I'm gonna go back and look at comments while okay. You're pulling up whatever you want to pull up. And
all right, so people want to know how I came to be a Christian. It was actually because of the Big Bang. I nearly left the Christian faith, and then there was this book, God and the Astronomers, by Robert Jastrow. And this is a famous book. He was at the Goddard Space Flight Center. He's director, so he's pretty bright. And he's an agnostic, but he was commenting on how the Big Bang made philosophical problems. And I said, this is attractive. So when I nearly left the Christian faith, the one thing I hung on to was the Big Bang. So let's not say that I'm rejecting the Big Bang because of theological things. It was the thing that kind of helped me believe. Because if the universe had a beginning, it's like, well, something had to start it. So naturally for me, just like what you said, you can be a Christian and believe in the old universe. And I did for a long time. That's what kept me in the faith. This one book, when I nearly left, kept me in the faith. Now, how is it that this all got overturned? Well, I think the fundamental thing that I liked about the Big Bang and that we're realizing is there had to be a beginning. So we can, you get into problems with thermodynamics and really common sense. The stars are going to burn out at sometime. That really just suggests there was a beginning. We don't have to get into all the theory. So I'm just prefacing all this. I came from this favorable to the Big Bang on theological reasons. I said, that's kind of nice to think. Science is proving that the universe started and something had to get it. If the universe started, something had to start it. And from what little I know, we really don't, even if we assume the Big Bang is true, we can't describe what caused it. Something, this has to do with kind of just like incompleteness or whatever. You can't, there's something outside of the system has to be able to describe it adequately. So I'm just prefacing that. So I have also watched the quote unquote evolution of Big Bang theory and criticisms of it. It has gotten so good to this point. When I began to be skeptical was in the year 2000 or so. And I said, I'm curious if speed of light could be variable. And where was it that it started to appear? It was in fixes to the Big Bang theory. And so in your discussion with Leo last night, he talked about inflation. A lot of respectable physicists, including Nobel Prize winner Roger Penrose, are critical of inflation theory. And one of the alternatives is variable speed of light. And I'm just like, wow. Now I began to be a little more curious. I was a extended study student. I just finished my third degree at George Mason University, 2001. And then in 2004, I see three professors, physics professors. Okay, these aren't history of science professors. These are physics professors coming out and sign that cosmology statement. Cicero Roy, Malabika Roy, and Minas Kafatos, a PhD from MIT. And I'm just like, so here I am reading these textbooks. I'm learning physics. I've learned physics. I got a minor in physics at that university. And now you have professors at the university saying that's wrong. As a student of science, you're like, that's interesting. What am I going to do about that? Then my curiosity was sparked. And then I took a class in supplementary quantum mechanics from this gentleman, James Trefle. Again, he's an agnostic. He's actually an anti-ID proponent. And I remember one time he's giving a big tirade against ID. And at the question and answer, I stood up. I said, Dr. Trefle, you're my favorite professor, but I'm a creationist. And he told the whole audience, by the way, Sal got an A in my class. But he has this book, The Dark Side of the Universe. He actually advocates dark matter. But there's a section here where he says, I have colleagues that have said, maybe he wanted, if I could just read this, just kind of, to be a little less nerdy, just put this in perspective. I recalled a bag lunch in a prestigious physics department where a prominent senior member of the faculty, I wouldn't dream of embarrassing him by mentioning his name, said that he often thought of leaving a sealed envelope to be opened 50 years after his death. In the envelope would be predictions about the way certain scientific controversies would turn out. At the top of the list would be the prediction that the interpretation of the redshift as evidence for universal expansion would turn out to be wrong. This book was written 1988. I have a signed, I got Dr. Trefle's autograph, this precious book to me. So, okay.
And I just want to interrupt really quick and say, these are not creationists.
These are not creationists.
These are not people who have a God agenda or anything else. These are just like secular professors. And the same with Eric Lerner, those who are criticizing Eric Lerner. He's actually an atheist, guys. For you atheists, he's on your side. He actually thinks the Big Bang is too much of a God myth. But anyway, go on.
There you go. So I'm just, I'm trying to allay all the criticisms. It's like Sal was in this purely because of religion. It's like, no, the Big Bang was the reason I believed. And there's one thing that it had in agreement with my present views, the idea of a beginning. So I think that's going to be hard to run away from just because the stars burn out. So however you want to do this, there is a suggestion of a beginning. We don't have to be too formal about that. And then I go to Johns Hopkins. I was a graduate student in applied physics. A lot of my colleagues were students who were working at the applied physics lab, building space probes. They were engineers like me, being retreaded to understand physics. They were being trained to help, in their job as they built these space probes to actually explore the Big Bang. I do recall kind of one funny incident in an astrophysics class. The professor is making a joke about young Earth creationists. I was kind of one then. And afterward, I talked to one of the students. He said, I'm going to church, now. And I said, where are you headed? He said, I'm off to church. I said, what do you think about him? He said, yeah, he kind of made fun of, creationists. I don't really believe in the Big Bang. And I was just laughing because we were the two best students in the class and his two best students were young Earth creationists. That was funny. And then in another class, one professor said, just between you and me, I don't believe in dark matter. And there are always these fellow graduate students, your rumors of professors dissenting quietly, and then you have professors openly. So the popular narrative that they want, that the scientific popularizers want to communicate is, people who oppose the Big Bang are cranks. And, there's competition for funding, I'm sad to say. There is a motive here. I'm not saying it's totally nefarious, but, you are competing for lots of money. And you have to, it kind of sounds sexy to, go to the funding agencies, especially Congress, say, we're probing the origins of the universe. And it's like, hey, that's really cool. And so those are my opening remarks. So, now we can nerd out. I just wanted to make those prefaces. I was thrilled you were sharing those papers. Many of them are peer-reviewed in respectable journals. And the one in Nature from 1974, I stumbled on that because it was followed up in 2021. It is showing a general trend that we're learning in the field of photonics, that there are many ways you can redshift something. So one thing I'd like to compliment you on is you talked a lot about the redshift. So the first thing, and expansion. The first thing is you can have a redshift due to motion doesn't involve expansion. Now, when I got a speeding ticket, it would have been nice if the state trooper would have, when he pulled me over, he said, the radar gun picked you up. And I passed him, which means his radar signal got redshifted. Now, I wouldn't use a defense and say, hey, expanding space, explain that. I really wasn't speeding. That wouldn't fly. Do we use expanding space to explain redshifts and anything except, like, say, the Big Bang? And I have a paper that said there is no direct laboratory proof that space expands. It also causes problems. You'd have to modify conservation of energy, because if you have two bodies, and they are attracting, there's a potential energy there. If you put space in between, you're adding to the potential energy. And I've read papers about this. This is causing some disconcert. I mean, yeah, Einstein's field equations may allow it, but just because you could have a mathematical equation and just start putting any free parameter you want doesn't mean the free parameters are correct. So Newton's law, force equals mass times acceleration, you could throw in free parameters like negative mass. It's mathematically correct, but it's physical nonsense. So the question is expanding space, whether it's nonsense or not, it's more important to say, is it true? And so I would just say a redshift. So the first line of criticism is, even if this is showing relative motion, it doesn't mean that it's due to expanding space. That is a conflation. It's an assumption. It's becoming an obfuscation, unfortunately. And so, of course, they'll say, well, then how do you explain this or that? It's like, well, that's not my problem right now. You got to deal with the fact that a redshift, just like that police radar gun, does not imply that space is expanding. In fact, you don't put that in your police radar gun calculations. Why would you put it anywhere else except to rescue the Big Bang? And so that's the first thing I would pose. Now, I heard that, they said general relativity explains that. It's like, no, not necessarily. It could. It doesn't necessarily. Like I said, if you have these Einstein field equations, you can have all these parameters and they're free, but you have to constrain the parameters to reality. You don't just make up the parameters to make your theory work. You have to constrain the parameters to any physical observation or direct measurement you can make. In the absence of that, it's a speculation, and it doesn't justify it being true. So let me just attack that briefly, because you talked about the James Webb Telescope. I would like to cover what people are critical of Michael Disney. Can I share my screen here?
Sure.
I'd like to share who he is. Because, they can pick on Eric Lerner. They're going to have a little harder time picking on Michael Disney. They'll have an even harder time picking on Roger Penrose, who is a Nobel Prize winner. Okay, you could share.
And who doesn't believe in inflation, right?
He's critical of it. Yeah. By the way, just look at all the articles on the people critical of inflation. It's really kind of funny now. It's becoming kind of a religious thing. So you quoted Michael Disney. Let's see who he is. They're not going to be able to accuse him of being a crank. And you read from what he wrote. Michael Disney is an astrophysicist. He discovered the optical component of the Crab pulsar in 1969 with John Cockey. This was the first optical pulsar ever observed. He was also one of the pioneers in the discovery of low surface brightness galaxies. Disney was a professor at Cardiff University until his retirement in 2005. Disney is an outspoken critic of the theory of cosmic inflation. He was co-author with Alan Wright of the humorous and often misattributed short story Impure Mathematics. You can take that down for the time being. He's not a crank. And So the article that you read was from about 2005. Guess what? That was his retirement farewell. I'm not going to
Really?
get fired for saying this because I'm going to retire. So let me write this. I'll tell you guys what I really think. You can't fire me. I'm retired. Ha ha. So it's really great for someone to finally say, hey, I really was your colleague, but, I wasn't going to,
Yeah.
stir the pot, so to speak. So
And by the way, for momentarily, I have gone through and read the chat, so I've starred a bunch of comments, and we will get to those at the end. But I want to give Sal an opportunity to make his presentation, and then I will answer some of your comments because there's a lot of, obviously criticisms, and but that's fine. And there's a really funny one, but anyway, go ahead.
I want to say thank you for letting me come on, Rebekah.
Yeah.
So it was raised about the Tolman surface brightness test, and this is relevant to the James Webb Telescope and even, believe it or not, even the Hubble telescope. The Tolman surface brightness test. The Tolman surface brightness test is one out of 6 cosmological tests that were conceived in the 1930s to check the viability of and compare new cosmological models. Tolman's test compares the surface brightness of galaxies as a function of their redshift, measured as Z. Such a comparison was first proposed in 1930 by Richard C. Tolman as a test of whether the universe is expanding or static. So now let me go to Michael Disney. And so what I'm pointing out here, the relevance of all this is, okay, why don't I just read Michael Disney's account here? I'm just pointing this out. This is well-known stuff, guys. All right, this is not in the corner. This whole thing about whether redshift implies expansion can be falsified by the Tolman surface brightness test. Like I said, you don't invoke expanding space to say, oh, the police, I wasn't speeding, officer, it was expanding space. That wasn't me heavy on the accelerator. Okay, so this test was to actually say, okay, if redshift does cause expansion, these are the consequences. So now I'm going to read what Michael Disney said. However, finding more direct evidence for the universal expansion must be of paramount importance. In the 1930s, Tolman proposed such a test, really good data for which is only now becoming available. And remember, this is 2005 in the Hubble era, not James Webb. Tolman calculated that the surface brightness, the apparent brightness per unit area of receding galaxies, should fall off in a particularly dramatic way with redshift. So dramatically, in fact, that those of us building the first cameras for the Hubble Space Telescope in the 1980s were told by cosmologists not to worry about distant galaxies because we simply wouldn't see them. Imagine our surprise, therefore, when every deep field Hubble image turned out to have hundreds of apparently distant galaxies scattered all over it. Contemporary cosmologists mutter about evolution. Okay, evolution to the rescue again. We'll have to have a different galactic evolutionary thing because this is obviously inconsistent with our understanding of things. Okay, it's just kind of funny. But the omens do not necessarily look good for the Tolman test at high redshift. If expansion were to fail, then so would the entire superstructure. The entire superstructure. As I said, we don't, you can take that down. Thank you, Rebekah. We don't have direct evidence of, how would we do an experiment to do expanding space? And then how would you start to reconcile it with potential energy? I mean, this is problematic. I'm also reading that you have 0-point energy in quantum mechanics, and it's starting to cause problems with, like, I don't know what we're going to do. When we expand space, what happens to the 0-point energy? That's affecting quantum mechanics. You will not mess with Mother Nature and quantum mechanics. So, you can invoke all of these things like negative mass, expanding space, but it has consequences. And if it disagrees with other laws of physics, you better be very cautious. But what takes priority are observations And that's why I really love that particular. He said, imagine our surprise. And just like, yeah. And then you get the same thing with JWST. Only worse, because now you have people. I'm going to just quote someone. This is, let's see, do I have it here? Oh, here. You could bring this up. No one was expecting anything like this, says Michael Boylan Colchin of the University of Texas, Austin. Galaxies are exploding out of the woodwork, says Rachel Somerville of Flatrion Institute. This is way outside of the box of what models were predicting. And this is the best one here. This is, right now, I find myself lying awake at 3 a.m, says Allison Kirkpatrick, an astronomer at University of Kansas in Lawrence, and wondering if everything I've done is wrong. Okay, this is not the stuff of vindication for the Big Bang. If you are having a theory and you're so proud of it, you don't have apologies like that saying, I don't know what to do. So the first thing was the Hubble Space Telescope. It's like, oh, we're told you're not going to see it. Now we have to put another epicycle in. Then now you have these galaxies like ellipticals that shouldn't be there. Now we have to put even more epicycles in. And now we have these galactic evolutionary cosmologists saying, I'm wondering if everything I've done is wrong. That's not a sign of a healthy theory. Okay, when Copernicus, you can take that down. When Copernicus gave us, the heliocentric model, the epicycles were gone. We had confidence in it. Anytime you had a new observation, you were able to reconcile it with eventually what we found, celestial mechanics, Kepler. Now, and there were a few tweaks that we got with general relativity, thanks to Einstein. But by and large, by the time Kepler got it, it was good enough to navigate our space probes around the solar system. And you didn't have to keep appealing to epicycles that had no explanation. You're just curve fitting. What's happening here is if you had a simple theory, you'd be able to explain it with recourse to that theory. Just like the solar system motions, you have one theory, celestial mechanics. And I have a book where it was a chapter on just the orbits of this. This is problematic when a theory has to be fixed with so many epicycles. You'd like it to fit in just one nice, maybe even a page. Electromagnetic theory fits on an index card. So much of modern technology fits on an index card. You don't have bazillion epicycles to fix it. It's 99% accurate for everyday stuff. So I'm just saying, all right, so I'm seeing stuff like this. I'm hearing my fellow graduate students be kind of skeptical. I'm hearing my professors be skeptical. And you feel like kind of the truth is being suppressed. What am I to think? So I'm just saying, I'm not saying that you have to buy into all this, but I'm saying though that the Big Bang is not as on a strong foundation as other disciplines of science. And Richard Liu, and I had to dig this up, and this is why I'm really glad, Rebekah, you invited astrophysicists to come, because there's some papers that I'd like them to review and comment on. And one of them, Richard Liu, said, well, if the microwave background radiation is cosmic, it should create shadows. Those shadows are missing. He published a peer-reviewed article in 2012, and I've not heard really good rebuttals of it. If you have some comment while I look this up, Rebekah.
Yeah, well, okay, did you find it, or are you still looking?
Yes, I just found it.
I have a lot of because I have a lot of comments, but yeah, I don't necessarily want to start them.
Okay. All right, September 5th, 2006. The apparent absence of shadows. The apparent absence of shadows where shadows were expected to be is raising new questions about the faint glow microwave radiation once hailed as proof that the universe was created by a Big Bang. In a finding sure to cause controversy, scientists at the University of Alabama in Huntsville found a lack of evidence of shadows from nearby clusters of galaxies using new, highly accurate measurements of the cosmic microwave background radiation. a team of UAH scientists led by Dr. Richard Liu, a professor of physics. He's a professor of physics, okay, peer. Used data from NASA's Wilkinson Microwave and Anisotropy Probe, WMAP, to scan the cosmic microwave background for shadows caused by 31 cluster of galaxies. Quote, the shadows are a well-known thing that has been predicted for years. This is the only direct method of determining the distance to the origin of the cosmic microwave background. Up to now, all evidence that it originated as far back in time as the Big Bang fireball has been circumstantial. If you see a shadow, however, it means the radiation comes from behind the cluster. If you don't see the shadow, then you have something of a problem. Among the 31 clusters we studied, some show a shadow effect and others do not. Other groups have previously reported this type of shadows in the microwave background. Those studies, however, did not use the data from WMAP, which was designed and built specifically to study cosmic microwave background radiation. And so there is something here that you could take that down while I look for my next slide. There is something here. Did you have a comment? You're muted. You're muted, Rebekah.
So I wanted to ask you, Sal, did you want to expound on those papers that I talked about with the redshift and the time, like the pioneer and the time dilation? Or did I do it? How did I do on explaining those? Was it? It was.
You did wonderful. Well, this is hard stuff. I could tell that you're trying to formulate your words, and normally you just flow. And I said, okay, this is great. She's becoming a nerd like me. She's stuttering when she's talking, just like me, and just like, yeah. Oh my goodness, I'm turning her into a nerd.
Hey, I got the glasses too.
Oh my goodness. Yes. Okay, I will go to what you did because you were so good. Let me just tie down. Let me just quickly close the thought on Richard Liu. He had this to say. He had a table, and this is really our point. He said, what we really like to do is take our laboratory experiments and show that we can apply them to the distant universe and be satisfied that our theories work all the way out to the reaches of space. The problem with the Big Bang is we don't have that. So he says, he gives a list of all the things we can do in our laboratory established physics. And then he points out what has the basis of the Big Bang here. If you want, you could bring this table up. So he shows laboratory-based physics, planetary orbits, tides, X-ray bursts, white dwarfs, etc. And there are lots of things. Then he points out the Big Bang is based, what laboratory-based experiments do you have? It says, the redshift, expansion of space, unverifiable, the Big Bang, far into the future, dark matter, near future as always, dark energy, far in the future, inflation, remote future. Okay, so this is comparing laboratory-based science, what I like to call everyday physics. It's a little more sophisticated than that. You don't have everyday physics that comports with the Big Bang. That's why we have this unsettling feeling from people that don't have a lot of theological commitment, like, a variety of people. So, and I'm just gonna, before we go on to the things you requested, this is what Richard Liu said. The cosmic microwave background temperature was predicted by Big Bang theoreticians. He's being snarky here. Well, the prediction by Gamow was off by an order of magnitude. Order of magnitude is like roughly by a factor of 10. Where do you draw the line?
I read that, but I wasn't sure. I'm glad you have a citation for that, because I read that somewhere. But I did,
and I was reluctant. Correct? But someone of rich. Okay, I got to tell you, I'm reluctant if I read it from Eric Lerner. I'm not trying to disrespect him, but my comfort level is higher when you have a professor in a secular university publishing in peer-reviewed articles and saying that. I'm like, now I can, we have someone of good authority. If he teaches at a university, he could say that, and he says that. if he's really wrong, his peers will call him out on it. At that, he's still he's a distinguished professor, by the way, University of Alabama, Richard Liu. So this accusation of crank, that's not going to fly. He said, where do you draw the line? How would you like the temperature of your room to be increased tenfold? Okay, we can revisit this. And then he had the experiments, the analysis that showed this isn't cosmic. It looks probably like it's local. And we can get back to that. But now to the topic of red shifts. And you can take this down while I search. So
that's right. And that's something I didn't mention in tonight was the axis of evil, that we see the cosmic background radiation, the fluctuations go along with the elliptical of the solar system, which is really weird if it's coming from the distant universe, because we wouldn't expect fluctuations like to match up, to line up with our elliptical.
Okay, so here's an example. So what we call Doppler redshift is like when the police radar gun is trained on you and you're receding away from him, you'll get a redshift in the signal. I'm presuming people know what redshift means. It's a lowering of the frequency or lengthening of the wavelength. They use the word red because the red is kind of in the lower, long wavelength end of the spectrum, electromagnetic or visible light spectrum. There are numerous ways light photons or electromagnetic photons can be redshifted from their original frequency. One of them is relative motion, as demonstrated and proven by police radar guns. But there are also physical experiments where electromagnetic radiation going through a inhomogeneous medium and varieties of medium. Different mediums give maybe different characteristics, but under certain conditions, two stationary objects, that police radar gun, if it were firing through certain kinds of things that you actually do see out in outer space, you would get a Doppler-like shift. It's called a Wolf shift. This has been confirmed in laboratory experiments, which is more than I could say for expanding space. So where am I going to take priority? Laboratory experiments or experiments with man-made devices or some theoretical thing that's already failing the Tolman surface brightness test? I need to point out, it hasn't succeeded. It hasn't been vindicated by Tolman surface brightness. If anything, it's good evidence that it's already failed. The only people that are holding on are like the people up at 3 at night saying, gee, was everything I've lived for wrong? Okay, it's on its heels, guys. The people kind of sense something is amiss. I mean, I'm just seeing it in the literature. You're seeing titles like Cosmology and Crisis. So
okay, well, you know what? I do want to. I've been watching the comments, and this comment goes along with. I am going to go back through all the comments of hopefully we have time, but this one is appropriate. Nicholas Lamar says Alison Kirkpatrick was lied about in the I Stay Awake All Night article. She said it, but context was altered, and she has personally clarified. And I'm not sure what she's clarified, but I think what she clarified is that she wholeheartedly believes in the Big Bang, and she wasn't trying to say the Big Bang is wrong, but that the things within the model is like some of these things that were expected in the model are wrong.
And that's fair.
Yeah.
You know what? This is what I got to say. When you believe it despite the evidence, that's faith. That's not science. So sure, she believes it. Where's the proof? That's where I get exercise. You'll say, you quoted her out of context. She still believes it. It's like, okay, that's fine. That's a religious belief at this point. It's not experimental fact. When you have to have a promissory note to fix your beliefs, that's a faith belief. That's okay. Just don't call it science. Say that's my belief. That's my faith belief. Don't call it stop calling it established fact. So it's fine. If you put the Big Bang in the religion department, I'd be happy. You put electromagnetic theory in the science department, celestial mechanics, geometric optics, basic chemistry, quantum mechanics, et cetera, et cetera. You put that in the science department. You put the Big Bang in the philosophy and religion department. That's how I feel. So, but thank you for the comment.
Okay. Anyway, sorry to interrupt you. I just wanted to put that comment because it was appropriate for what you were
Yes,
saying.
absolutely. Absolutely. But the point is there's a problem. Okay. You wouldn't have to be making clarifications if there is are you going to say there, I'm just saying, is anyone at this point going to say there's no problem? It's all fine. Except maybe for someone like Professor Dave. Anyway, so I'm going to take this one down, and I was so proud of you. You can bring this one up. Prestigious scientific journal, Nature. Okay, so what experiments? Lee, I want to address Leo's comment. I did see it. He said that has nothing to do with galaxy redshifts. It's like, no, a later article said it's everything to do. Because if we have alternative explanations for the redshift, that's relevant. We don't know what causes the redshift. Now, for a long time, I'm fine with the idea of the galaxies moving. It raises other kind of questions. And I have to say, I'm really proud of you, Rebekah, because if you see all the galaxies moving away from you, that means we're special. And I'm like, yeah, I guess that would be philosophically unsettling in certain quarters. That if
you mean if they're moving away from us, but space is not expanding?
Right. Because that would mean we're in a special location where we see everything kind of, equally distributed. That means we're close to the center of all the action. Or you could say the center of the universe, depending on it. But I said, it still, I would be quasi fine with that. That was where people were like, this is unsettling that we're seeing redshifts. And so if you say moving, it doesn't immediately say that it's expanding. So, okay, we have the Tolman surface brightness test. Looks like it is at best not even vindicated, probably failed. But let's now explore the question of whether the redshift actually indicates motion. So you cited this prestigious scientific journal, Nature. It detailed the anomaly. It's there. And people say, that's old, that's 1974. It's like, guys, that's a valid experiment. It can be repeated. There's nothing stopping us from, building more space probes and actually conducting these experiments. But on some level, we can even do some closer to Earth experiments with plasmas or whatever. So, but the point is, there's lots of plasma in space. It's more dilute than what you have in the solar corona, but there's lots. Now, just a minor point. I don't think the probe was actually inside the solar corona. Its radio signal passed through the solar corona. So we know, it's a man-made device. We know what frequency it was emitting at. When we received it on Earth, after we adjusted for all the relative motion of the space probe, the Earth, the sun, we factored out gravitational redshift. We had a residual redshift that was due to the solar corona. This is what this article highlighted. This is relevant because there's tons of plasma in space. This is only, passing through a few million miles of plasma, but it was concentrated, so it made a good experiment. But out in space, you have bazillions of miles. In a dilute plasma, you could theoretically have a redshift also, and it would also follow the Hubble relation of distance and redshift. So the more distant it is, the more redshifted it is. This is why this experiment was really important. And I'm just saying, if you're going to dismiss this, I'll just say we could repeat this experiment, which is more than I could say, and have successful experiments, by the way. I expect that, which is more than I could say for the Tolman surface brightness test for the Big Bang. And then you cited, oh, I love that article you gave. I've since lost it. Was the one by Trinchera. And at the very end, he said, we can extrapolate this experiment to other redshifts, and it would put into question cosmological. And it was great that he got that in peer review. So I'm just going to take this one down, and now we'll go to I'll show a paper I'd love to. Okay.
Do you want me to pull up
We were
that article, or you're fine?
Could you put up that article? Because there's some question
Yeah.
about it. Leo in the side chat rightly said that has nothing to do with galactic redshifts. Just for the record, let's just set it straight that this article was specifically explicitly mentioned it as a problem for cosmology.
Yeah, go ahead and do something else while I'm finding this one. Okay,
so let's talk about time dilation here. And this is really devastating. So we have alternative means for the redshift established, and we have any number of future experiments in the study of photonics. There are like 30 different ways we could redshift things, at least 30 different ways without relative motion. And we're trying to figure it out. The Wolf effect I thought was compelling. This paper by Trinchera suggests Wigner crystals. There are other papers by laser experts, photonics experts. We can start to verify these mechanisms in the lab, and that's a lot better than verifying it in people's imaginations and free parameter extrapolations. So regarding time dilation, you can bring this up now. You can put that up. I did this. This is an This was a redo of something I had to do in graduate school. The first day of graduate school, I had to do the following proof. It deals with time dilation. So let me explain time dilation. There's something known as the twin paradox. If you have two fraternal twins and one of them stays on Earth and his fraternal sister, rides a spaceship and gets to 99.999999996% of the speed of light. According to special relativity, 1 day in her clock would be like 1,000 years for her twin brother, and 1,000 years for her twin brother would be as a day for her. That obviously alludes to biblical reference. A day is 1,000 years to the Lord, and 1,000 years is as a day. We actually show that special relativity shows how this is possible. This has been verified experimentally. Not to this level, but we have like particle accelerators. We also have GPS satellites. The muons coming through, the changed half-lives. There are all sorts of things. Many experiments confirmed it's beyond a shadow of a doubt. But the important thing is velocity affects the clock. The higher the velocity, the slower the aging, the slower the clock. And just, if I may brag a little bit,
I think I said it backwards because I think I said it speeds it up. Did I? Or did I say it?
I don't remember.
Okay.
But we're correcting it now. So the faster you go, the slower your clock runs. The slower you age. Okay, let's say the slower you age. Now, okay, what does it mean the slower you age? Would it be slower in your view? It's like, no, you wouldn't personally notice that you're aging any slower. But an observer who is in a slower reference frame, like the twin brothers say, like, oh, she lives forever, and here I am aging. Okay. You can derive this, by the way, from basic electromagnetic theory. This is what I had to do. I started with Maxwell's equations, and this is just 20 seconds here for electromagnetic theory. This is real science. We have the modern day because of electricity and electromagnetism. And I start off with the electromagnetic wave equations and combined with the Michelson-Morley experiment, and we assume a constant speed of light. We do a lot of math, and I had to, in graduate school, the first homework assignment, I had to do this derivation. Now, at the time, the professor gave us so much, he spoon-fed us with so many starting points. I was able to do it in 4 hours. When I redid this, it took me probably 40 hours spread over 8 weeks. So this is real special relativity, electromagnetic science. So this is going to play a factor in evaluating whether the redshift implies motion. So the idea is, if we could show that the clocks of objects moving fast slows down, then that would lend evidence for the Big Bang. If, on the other hand, the clocks don't change, that's evidence against the Big Bang, because that means there's not even relative motion. The redshift is caused by something else. So hence we have David Crawford, another professor, retired in astronomy. So this is really funny. When you want to criticize the Big Bang, you have a nice 30-year career. And this is going to be similar to your diagram that you showed with Crawford. This is even better. He actually, it escaped my notice, but Crawford said, I have even something better. It's the gamma ray bursts. So gamma ray bursts are big energetic bursts that happen, I think it's aperiodically in galaxies. And they last for a certain amount of time. I'm not really schooled in this, but basically, it's just kind of like when you have traffic, customer traffic in a store. It's not periodic, but you could tell when you're having more or less during certain times of the day. So what you would want is you would like to see a greater, the higher the redshift, you want a greater proportion. If you're a Big Bang advocate, you'd want a greater proportion of the gamma ray burst to be longer. And so he illustrates that with this red line right here, this red line. So the expected thing is you have this distribution of customers, so to speak, or gamma ray bursts, and you're supposed to see all the dots kind of just, be symmetrical about this red line, not symmetrical over the horizontal line. The horizontal line says no time dilation. The redshift then does not indicate relative motion. So that also kills universal expansion. Already the Tolman test has falsified it as far as I'm concerned, or at least you need a promissory note to fix it. Now you have this that's saying not even the redshift is probably relative motion. It's stationary. And you have the Hubble relation explained. It's dead in the water. And then you have the same phenomenon with quasars. Hawkins pointed that out. And he said, we're not finding time delay. It's kind of the same thing. You're expecting to see these random points, even though they're presumably random, you want it to kind of just have a bias along like this, a red line, absent. So so on the left side, you have, near to us. On this side, you have distant galaxies, more redshifted. And the reason this is even better than Crawford was saying, the supernova, I showed that had the same problem. And the only way that they have made papers that said there was time dilation, he found a subtle circular reasoning. Circular reasoning, I wouldn't say it's nefarious, but he said they were assuming the thing they were trying to prove. That's why they got all this time dilation proof. But when you have unbiased data that's not corrected with Big Bang add-ons, when you just look at it like this, no time dilation, no relative motion. So you have the quasars, you have the gamma ray burst, the supernova, you have the Tolman surface brightness test. And there is something I want to say. It's like, do you give up on a theory just because it has problems? I would say probably. If it's severe enough, yes. If it's severe enough, yes. Huxley, Darwin's bulldog, said, the tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. The slaying of a beautiful hypothesis, and I'd add this, by a single ugly fact. I've given 4 ugly facts already. I've given a 5th if you include the lack of shadows.
Wait, there's something we need to clarify here, Sal, because Nicholas is under the impression that this is your own calculation, not a peer-reviewed paper. Can you clarify?
Okay, so this is an archive. It doesn't get in a journal, but it does have to undergo peer review to get in the Cornell archive. I mean, it's considered good enough. It is by David F. Crawford, Sydney Institute for Astronomy, School of Physics, University of Sydney. He's a respected astronomer. This isn't my calculation. My calculation was what I was showing earlier. That was a homework assignment that I color coded. That is mine, but this is done by other people. That was just showing.
I also have to clarify with this because Frank P is confused. He's thinking that you're saying time dilation is not a real thing.
No, it is.
This is what we're saying is that, yes, we're acknowledging that time dilation is real. The question is, do we observe? We should observe that in things that are moving quickly away from us. And the problem is that we're not showing it, our observations don't match up with what is expected if these objects in space are moving quickly away from us. So it's not that Sal is not saying that time dilation doesn't exist. He says it should exist and it's not being observed. So therefore, maybe we should question whether or not these things are really moving away from us at a quick speed. If it's not showing the effects of time dilation, then it's maybe it's not moving away from us.
Right. Exactly. So, and he specifically says, okay, what does he say here? And by the way, those are actually great questions. No, this is not me saying it. I'm not going to represent myself as an authority. I'm just an interlocutor, a student of science. Okay, I'm not a professional researcher in these areas.
And we are inviting, if there are professional researchers that want to come on and address these issues, I would be ecstatic to have a professional on to discuss these issues. So
David Crawford, okay, this is what's great. I can, this is where I kind of was glad to help Rebekah because she had the book, I gave her the paper by Disney. She read the book by Lerner, but I also had, these other references I had found. And so a professor of physics and astronomy, he's qualified to discuss this. And he specifically said, if I may read the abstract, gamma ray bursts have been observed out to very high redshifts and provide time measures that are directly related to intrinsic timescales of the burst. Einstein's theory of relativity is quite definite that if the universe is expanding, then the observed duration of these measures will increase with redshift. Thus, gamma ray burst measures should show a time dilation proportional to redshift. That's that red line in the graph earlier. An analysis of gamma ray burst data shows that the hypothesis of time dilation is rejected with a probability of 4.4 times 10 to the minus 6 for redshifts out to Z 6.6. Traditionally, the apparent lack of time dilation has been explained by an inverse correlation between luminosity and time measures together with strong luminosity selection as a function. That part I'm not quite understanding, but it's important that he's saying everyone knows this is a problem. Everyone knows that this is a problem who should be in the know. He's pointing that out, and that they have had another epicycle, another free parameter, another promissory note. And he's trying to kind of put a nail in the coffin of this. So this is a known problem. Again, like I said, the whispers in the hallways of physics departments, this is one of them. You wanted to say something.
Can we clarify for those who are watching, and maybe they haven't been watching the whole thing, but what would you expect if they aren't moving at all? Like if it's not moving, so what does that tell it? What's the conclusion that you're trying to come to, or what do you what do you think is true?
All right, you see these little dots? These are measurements of how long the gamma ray burst lasted. So like, let's say this is, I don't know. There's amount of time that the gamma ray burst lasted. So if you have like an explosion, you see how long it takes for it from initial to finally settles down. So to the commenter's question, what you would expect if it's not moving is that all these measurements would be kind of more symmetric with this horizontal line. If it is moving, it'd be more symmetric. It'd start to be symmetric with around this red line. So the absence of time dilation here, this graph just tells, picture's worth 1,000 words. So that's the best way I could say it. All of our measurements of the lifespan. Okay, so we had that twin paradox thing. Let me just bring this up. So just like people, we have different lifespans. So let me just try to relate this to the picture here. We so we have the lifespan. You know, what's the lifespan of an average human? What for a woman, like 80 years? Okay, so it's going to be an average. You have some women living less, some women living longer. So now let's say she's moving real fast and her brother is somehow, quote unquote, somehow observing this, or at least has a record of it. He's realizing she's living to be 200 years, 400 years old. And that's how he can say, oh, she's moving real fast, because there's no way, it's just unreasonable that she's living 2, 3, 4,000, 10,000 years. And she's just not aging. Now, if she weren't moving, she would have a normal lifespan. So relating this to the gamma ray burst thing, we might say then the gamma ray burst has a lifespan. And so these are the dots of the lifespan of the gamma ray bursts. We should see an increasing lifespan with increasing redshift. How about that? Does that sort of, I'm trying to relate it to everything.
You're doing great. Yep.
Okay. Increasing lifespan with increasing redshift. And what we're seeing is, no, it just let me say this. It shouldn't be symmetric. Can I correct myself? I made a slight error. It should be parallel. The average age, if we bend this, should be kind of parallel to the horizontal line and it's not, if it were Big Bang, it'd be parallel to the red line. And that's what he's saying in his abstract. So thank you very much. I appreciate the questions, because at least someone is curious enough finally to ask.
Yeah.
So thank you.
There's some really good comments coming in, and I there are a lot of comments from the past I still want to go over, but let's put this. Nicholas says, let's be honest. Crawford admitted this wasn't proof of a static universe, just what he considered evidence supporting it. Yes, we totally agree. We're not here saying we have proof that the universe is static, that space is not expanding. We're just trying to show the evidence that redshift may not be expansion, and that we're just trying to show the possibilities. And there's good observational evidence that, redshift isn't what the standard model has considered it to be. So that's all we're trying to show here.
And he's putting the odds, I think, 4.4 times 10 to the minus 6. That's like 4 in a million chance that it's due to that there's time dilation. It's right here in the abstract. So why don't I just try to finish to be fair to Crawford, let's just read what he said in his own words. It may be possible to explain apparent lack of time dilation with a combination of gamma ray burst selection, some luminosity evolution again, in order to produce the apparent lack of time dilation. Everyone's acknowledging this is a phenomenon. However, the data are consistent with a static cosmology in a non-expanding universe. The data are consistent with a static cosmology in a non-expanding universe. And then he retires. Okay.
Oh, he retired too after doing this?
Yes. Of course, that's what else are you going to do?
Oh my gosh. Okay, so do you want me to pull up the other paper that you wanted to highlight?
Yes.
Okay.
Okay.
That's the redshift paper that you
right.
wanted.
If you can go all the way to the bottom.
Sure.
And thank you for finding this.
Yep. Wow.
Yes. Thank you for scrolling. This is really good. I want you to appreciate how hard this guy worked. And when I shared this with Rebekah earlier, she said, let's give thanks for Trinchera because he works so hard. So there's a conclusion here toward the end. It's probably the last couple sentences.
Well, I looked. I didn't see what you're looking for.
Oh, a little bit. Okay. It says, can you scroll down just a little bit? If you can make it a little bigger so I could read it. Thank you. Oh, this is a beautiful paper.
Oh, that's the appendix.
All right. Oh, there it is. It says Wigner crystals. Okay, I'm not saying that his model just a little higher. Okay.
I don't know. Oh, okay. Yeah. Here you go.
Just a little lower. Just a little. Oh, wait. Stop. I'm sorry. The discovery made in the study on how the radio signal under particular physical mathematical conditions undergoes a redshift should not only be considered a local phenomenon on a solar scale, but also a cosmic phenomenon on a larger scale applicable to all stars and galaxies, as it is exclusively dependent on distance of an astronomical object, the Hubble relation, on the density and temperature of the electrons in the surrounding environment, and on the wavelength of the emitted signal. And so there you go. We have an alternative explanation for the redshift. We have, other than relative motion, we have evidence there is insufficient relative motion to be causing those redshifts because of the absence of time dilation. We have evidence, we have pretty good evidence, at the very least, the Tolman test has not vindicated the Big Bang. It's looking negative. I'll score that a fail at this point. And then now we have, I mentioned in passing the microwave background radiation has problems with it because of the absence of shadows. And Richard Liu is very critical of that. And then we actually have alternative mechanisms for a local microwave radiation. And I found a paper on that. So I'm just articulating, these are things professors at my school were kind of hinting at and talking about, like the Wolf shift. Cicero Roy at George Mason had mentioned this is very problematic for at least quasars, explaining the redshift. And then we see that the quasars have absence of time dilation. I said, this is really bad. And so I'm just sharing with you all, okay, for me, as someone who likes condensed matter physics, where you can have real experiments to confirm your ideas, this is very unsettling that I'm seeing this momentum, cultural momentum for the Big Bang. And they're recruiting religious leaders saying, no, the Big Bang's good. I mean, I love Hugh Ross to death. God bless him. You say, Big Bang's proof of God. And just like, I'd say the beginning of the universe is proof of God for me personally, not scientifically, personally. But it doesn't have to be in the form of the Big Bang. It could be, I kind of like ready-made universe. That's, if you wanted my idea. I said, the Big Bang actually, both steady state, and I'm going to close with this a little bit. We can go to questions more. I'm loving the questions, but I have my cosmology book here when I studied this, and page 17. And I really appreciate the audience interest in this, and they have some good questions.
Yeah, and sorry, I'll just say this. Nicholas wanted us to finish the abstract. Every paper that is mentioned here is all in the discussion. Yeah. You can go and read it. We're not trying to be dishonest. The paper is quite long, and we're trying to bring out the relevant points. We're not being dishonest.
Exactly.
So, okay, go ahead. Read your quote, Sal.
During the 1950s and 1960s, the Big Bang and steady state models battled for supremacy. Critics of the steady state model pointed out that the continuous creation of matter violates mass energy conservation. Supporters of the steady state model pointed out that continuous creation of matter is no more absurd than the instantaneous creation of the entire universe in a single Big Bang billions of years ago. And it's right there, guys. And this is the book. This was the book in graduate school, and it has lots of general relativity and all that. So I studied this. What am I going to do? Page 17, you hear that. It's like, that sounds like a miracle. So you don't know where the matter is coming from. Something outside of our laws of physics, we could say the laws of physics are always true, but they're not always the same throughout time, or whatever. It's a philosophical semantics, game. As far I could just say loosely saying they don't want to admit it, but there are miracles along the way, that things you're never going to explain. And if you're going to invoke miracles, at least admit to it first.
Yeah.
And if you allow miracles, how about a ready-made universe where, the matter just kind of popped out in the right place? I kind of like, if you have no relative motion between galaxies, how about matter just happened to appear right there? That has obvious philosophical problems. But if you're going to invoke, I'm just saying, the steady state model, the Big Bang invokes miracles. They just don't want to say it. They want to pretend that they figured it all out naturalistically, and that's not true. Or they figured it out in ways that we could use our math, our limited minds, and say, we understand this, we got this, we figured it out. It's comforting to think we figured out the universe. Okay, it makes you feel like, hey, if I figured out the universe, then hey, I'm cool. Humanity's going to survive. But it's unsettling when you have to say, I have to appeal to something I can't really test or verify. I have to put faith in it. And what I see when someone's up 3 in the morning and they're saying, what have I lived for? I'm just like saying, okay, you have faith in the Big Bang. You're trying to prove it because you want to believe in it. You're trying to satisfy your faith and reassure yourself. That's totally fine. What's wrong with a Christian wanting to do that? That's totally fine too. And so, hey, if that's what is your faith belief, I'm thrilled you're trying to pursue it. You're wanting to defend it. It's a beautiful thing. But let's not represent that as something that's actually proven at this point. It's a faith belief. And I have a faith belief that if you have a stationary object out there and it just happened to be there, how did it get there? And it couldn't have been there forever. The universe had to start, right? Matter had to start, and it had to be right there. I like a ready-made universe. Now, that's not exactly a young Earth creationist model, but that has a lot of what I like. So there, I kind of thank you for this opportunity to share what's been on my heart. Rebekah kind of was calling me up and saying, hey, Sal, can you send me some more papers? And I started reading them again. I'm just like, I have so much to do. But I said, maybe I should, because this is what I lived for. I said, I wanted to study this. People know me as a biologist, and I'm really an engineer that got retreated as a physics student. So thank you.
Oh, well, thank you, Sal. And you know what? Let's get to some of these comments. This is from Germania. He says, can you or Sal tell us what the Big Bang model is? What's y'all's understanding of it? You don't have to agree, but can either of you state what science says about it? Can you do it in 2 sentences, Sal?
Space is expanding. Started from a hot beginning, expanded out. And just briefly, all the evidence that I've tried to lay out is showing we have observational evidence. It's not expanding. It's done.
Okay, so I have like 40 comments here that I've starred. So I'm going to go back and I'm starting at the top. And then
thanks for the comment, by the way, Germania. Yeah.
And Sal, a lot of these are not going to apply to you because you weren't here. So, but if you want to stay, you're welcome to.
Sure.
But you might not like some of these comments.
Well, I promised Rebekah I'll take a bullet for her because I was so mean to her yesterday. And so I'm trying to make it up. I'm groveling before her now.
And then, okay, we've been going 2 hours. I do want to give a chance. If there's somebody here that is burning to come on and kind of, offer an opposing viewpoint or, has anything that they want to, I want to open up the stream to allow maybe one person at a time to do that. And maybe only one person because, we've been going for a while. But what I would like is for that person to have some substantive things to say about the science. So if that's not you, then come on a different stream. Okay, now, but I'm going to go through some of the comments first. Okay, LB says, this was at the very beginning. He said, maybe if God would make a limb regrow on an amputee, then that is a miracle. I don't even remember what context this was, but I love spending my time, praying for people for miracles and things like that. And so I would love to see an amputee grow a limb, and I hope one day I will. I actually expect that in some time in my lifetime, I will see that. I have a great hope for that. And let's see, BS Lewis, thank you for the vote of confidence. I'm sure some bread has some surprises in her purse. Okay, so Seawolf says she tries so hard to weaponize science in her favor. Guys, I really am trying to be honest about what our observations of the world show. I admit when there's things that seem to be against the beliefs that I currently hold. But, I'm wondering if other people who call themselves skeptics are actually being skeptical about other things than God. Are you skeptical? And this is kind of a question I have for the audience. Is anything that has been presented here causing you to be skeptical about the Big Bang? At least have some doubt in the Big Bang? Because if not, I'm wondering if you're just like decided you're going to believe whatever you're told, whatever, and you've selected that scientists are going to be your guide for life, and whatever they believe is and whatever they tell you to believe is what you're going to believe. And I think there's a lot of people out there who that is the way they're living. They have decided to believe whatever the experts tell them. They've kind of made gods of scientists. And you know what? I am greatly appreciative of scientists. I have respect for what they do. I'm thankful for what they do because they've brought us a lot of great things, and they continue to do great work. However, they are fallible and they do have false beliefs. Many, and I'm sure I have false beliefs too, but scientists are just as fallible as anybody else with their beliefs. And I don't remember where this comment is, but I'm going to go ahead and answer it. Yeah, actually, here it is. Jerome asked, I'd really like to ask Rebekah why she thinks the Big Bang model is still the consensus despite all these papers. Well, I believe that there's probably a lot of factors involved, but one of them is that people don't like rocking the boat. And it's much easier, if you're taught something from the time that you're a child, and those who are critical of religion should understand this, right?
Oh, yeah.
So
Right.
if you're taught something from the time you're a child, and then even when you go to study, then it's reconfirmed to you as the Big Bang has been for most scientists. By the time they get to their field of study, they've already been completely immersed in this idea that this is true, this is true, this is true. And then the people they respect in the field, their professors and everything, are saying, this is true, this is true, this is true. And so they have learned not to question it. And many of them probably have never questioned it. So I'm sorry if they have. Great. I'd like to know what their critical responses are to the problems with the model. And like I said, I've invited people on, but I think that has a lot to do with the consensus, because even if someone does break out of that zone of not questioning the model, if they dare to break out of that, then they are ostracized. There's good reasons not to break out of it. So just like you guys are criticizing religion for being that way, well, science is also like that. Despite what you insist that, oh no, it's good to overturn. Yeah, we know that when science is done well, it's good to let the observations that we make speak for themselves and not be beholden to a theory. But you talk to people all the time, hear scientists say all the time that, oh no, even if they admit there's a crisis, they still say, but we know for a fact that the Big Bang is true. That's commitment to the model over the observations. And so I hope some people can see that. But I don't know.
Can I comment just a little bit?
Yeah.
It's what Michael Disney said. We have more free parameters, more ideas than we actually have measurements. So high quality science, like I mentioned, some of the fields like electromagnetic theory, celestial mechanics, geometric optics. So your glasses work because our understanding of geometric optics. When you can repeat, you have many measurements, experiments, you can validate the theory. The Big Bang does not have a lot of that. It can be perpetuated then because of it's actually, so he asked, going back to the question, he asked, why is this persisted? It's because we have actually a lack of experiments. Right now it has the momentum of just faith belief. And it can be perpetuated a long time. And so, well, science, part of science is making a hypothesis. And you'll say, well, assume it's a working hypothesis, it's true. And so in a sense, it still is an article of faith until you have an experiment to validate it.
And you have to have money to run experiments.
Yeah.
And if you don't have money, you're not going to get an experiment. And you know where the money is? It's with people who have careers, who have power, who have been dedicated to this model. And they're not necessarily interested in giving money to people who are trying to do an experiment against the model. I mean,
I'm not saying
that was in that letter of Cosmology. That was one of the complaints in that letter, is that the funding is not there to, for anything else except things that will support this model. And now here is my favorite comment in the whole chat from B.S. Lewis. He says, bread of life. It says right there in paragraph 2, sentence 3, God no existy. This is the best comment. Thank you, BS.
Thank you, BS.
Yeah. And, a lot of people are like, okay, and I think it was BS too, asking like, oh yeah, he says this, even if you guys debunk the entire Big Bang, the default theory is not Jesus. I agree. I absolutely agree. And that's why I announced at the beginning of this stream that, hey, it may seem a little weird. Why is a, Christian channel, I'm dedicated to sharing the gospel. Why am I bothering talking about the Big Bang? And I think it's tangentially related, but I did question whether or not I should even put any more like things related to science on this channel. But it basically, it is related, because if you believe that there's a natural explanation for the universe, then you're probably not going to seek God. You'll probably not recognize that there is a God. But when you start to realize that the natural explanation doesn't hold as much water as you were told, then maybe you will start to question and reach out for God. And that's what happened to my husband. And but even if like, there's a lot of people like Eric Lerner saying, look, the Big Bang, this is a God myth. Like this is, it requires God. And so, maybe if you don't want God involved, if you really want a naturalistic explanation that accounts for things, then you might try something else. Just a thought. I don't think the Big Bang is a good model for you, but anyway. So,
by the way, I've had a lot of atheist supporters say, "We're right with you, Sal. We hate the Big Bang." I wouldn't say a lot. I've had a handful say, "Yeah, I don't like the Big Bang. I think its science is questionable." Hey, diehard atheist. So he's echoing about Lerner. This is the sentiment. Many of the critics in the secular world who are Big Bang critics are atheists, for the reasons that Lerner is an atheist in not liking the Big Bang. So this is very interesting. You have creationists and atheists teaming up, being strange bedfellows. This is kind of interesting dynamic here. So
yeah, but why do we bother talking about this? Well, I simply don't think the Big Bang is true, and I don't want other people to think that it's true.
I'll tell you why
I want to talk about it. What?
I think studying, just speaking theologically, studying the works of God, science is a gift from God, in my opinion, and it's a way to see the things that he has made. It says in Romans, his invisible attributes, his divine nature, are clearly seen in the things that are made. I mean, even just studying these questions, you realize the size of the universe. I said, whatever made the universe is really powerful.
Yes. And I totally agree with
Yeah.
that verse in Romans.
Yeah.
And I believe it applies. Like it, I think when you look around at what has been created, you know there's a creator.
Yeah.
And at some level, you know there's a creator. Sorry, atheist friends, but in all this time, you haven't convinced me that, you have a good reason for not acknowledging the creator. So anyway, Sergey says, either way, the Big Bang could not have come out of nothing. Something must have been there before. Yes, good point. Okay, Leo Phileas says, somebody who doesn't know what type 1A, is it 1A? 1A supernova R is lecturing us about how the Big Bang is wrong. Let that marinate with y'all for a second.
It's not about us. It's not.
Yeah,
we're not lecturing. You have the papers. You can do. Okay. Just assume we're stupid. That's fine. We have done our duty to share.
Yeah,
people that actually do. There are people like Crawford that know what a type 1 supernova is. So.
And Leo, I do totally appreciate your comments in the chat. I do want to say, if there's somebody else who wants to come on after, because Leo had his opportunity for 2 hours last night to hit on the Big Bang, and so I want to give somebody else an opportunity if somebody else wants to come on.
Nice to see you, Leo. By the way, Rebekah kind of cringed when I said this. I said, I thought Leo did a great job yesterday. She said, Sal, I'm so mad at you.
I have to say I was pretty mad at Sal last night and today.
Because I was heaping praise on you, Leo. You see, you got me in trouble, buddy.
Yeah. Okay. So yeah, let's see. Okay, I'm skipping some of these. Titan says, link the paper in the side chat, please. Sorry, I didn't do that. Orge says, is Rebekah confusing the prediction of the Big Bang with predictions within the Big Bang? I think that's a good question. No, I tried to explain the levels that are required and how, Michael Disney said, actually, these are like 5 separate theories. So maybe what you would, call those predictions within the Big Bang are part of those other theories that are contained within the Big Bang. I don't think I'm confusing those. That's why we focused on redshift and cosmic background radiation, because those are the foundational pillars of the Big Bang. However, you can't just say, well, that's all you need, because if you're going to explain how the, all of these, if you're saying you have an explanation for why the universe looks the way it does right now, you have to include explanations for galaxies and all, every feature of our universe. You have to have some kind of working explanation for that, right? If you don't have that, then what the heck is your theory doing? Like it's all part of it. Do you want to comment on that, Sal?
Nice. Thank you for the question. I don't totally understand it. And the issue is space expanding? Is the redshift an indication of relative motion? If those are falsified, the Big Bang's done. And I'm sorry, I'm not directly addressing your question, but that's the real thing. It's not whether I'm confused or Rebekah's confused. The issue is whether the data support relative motion or expanding space. I've tried to make the case that those have been falsified quite decisively.
And by the way,
Go on.
Oh, I was just going to say, I'm not watching the chat right now because I'm going through the older chat messages, so I may miss some. But Bro Guy says, I think we're kind of beyond any kind of logic here. I think this is all about Rebekah trying to defend a story she really likes, that she feels explains everything, and she finds satisfaction in that. I do find great satisfaction in the story I believe that Jesus died on the cross, he rose again, and that we can have eternal life in him. I find great satisfaction in that. I have great satisfaction in the story. I believe that in the beginning, God created the heavens and the earth. And so, yeah, I have great satisfaction in that. And that is connected to why we're talking about this, right? I'm not trying to prove that that story is true. I don't think I can prove that that story is true. But with the Big Bang Theory, I think if it is a scientific theory and not a story, then it should also be able to be proved untrue by our observations. And I think it is. Evidence against it is mounting. So there's two different things going on here. There's a story I believe, and then there's something that's being presented as a scientific explanation for the universe, and I don't think it holds up.
Could I respond a little bit? I know the question is directed to you. I like the science because it reassures me in my faith. I nearly left 20 years ago. The more I studied science, the more Romans 1:20 became to resonate with me. I said, there's got to be a God. And I've heard the same thing from some people. They said once they started to study the science and believe in God, they wanted to study more, not less.
Yeah.
And that's what happened to me.
Excuse me, but says, Rebekah, you need to get to the root of why you don't feel embarrassed by doing this. Yeah. Well, I understand that to probably the majority of people watching, I'm making a fool. You think I'm making a fool of myself. And so I don't feel embarrassed by doing this because I think I'm telling the truth about reality. So, but obviously you don't think I'm telling the truth about reality, or you think, you have a different idea, and that's fine. But yeah, I think I'm at the root of why I'm not embarrassed about doing this. It's because I'm not a slave to credentials. I'm fine with being wrong about some things. I'm fine with having that pointed out to me. I'd be happy to have experts on here. So I have nothing to hide. I'm just looking at the evidence, and I'm, like I said, I feel confident in what I believe about reality. And if I'm wrong about some things, I'm happy to adjust. So that's why I'm not embarrassed about doing this. Andrew Cummings says these same researchers also found that many irregular galaxies colliding galaxies, etc. Okay, they found, I don't know if many, well, they found some colliding galaxies. I don't know how many irregular galaxies they found, but they shouldn't have found any elliptical galaxies. They shouldn't have found any spiral galaxies. And actually, at those far distances, they shouldn't have found any galaxies. So how about if we deal with those issues? Because this is just ignoring the problems that we're bringing up. So,
and to reiterate, as Michael Disney said, they were surprised when they saw it. He said, that doesn't bode well. Tolman test failed. Big Bang failed.
Nicholas says, I've given you 3 astrophysicists have refuted it and a link to an article on it. So yes, scientists have refuted it, and he's got no backers. Actually, I didn't, if you posted a link, I didn't get it because it doesn't allow to post links. So if you could email it to me, that would be great. Sometimes it'll let you post links in the comments and like the actual comments instead of the side chat, but sometimes it deletes those too. So I don't really know how people sometimes get links in there, but I don't have it. But you can also just tell me where to find it if you want, and I'll look for it.
Yes, thank you for the comment.
And Gur says, just got here. Did Bread of Life just discover something that would revolutionize the field of science, or not really? Well, it's all sitting there available. Nothing I discovered. So,
well, we discovered it for ourselves.
Yes.
But other scientists found it.
Jerome says no atheist should care about any of this. This has nothing to do with theism at all, and nobody needs to have a complete model of cosmology to deny Christian theism, especially. Just run Occam. Easy. Yeah, thank you for that comment, Jerome. Yeah, and maybe for you this is unconnected, and that's fine. Okay. Leo says, I explained to Rebekah in our discussion yesterday that differences in calculations for the rate of expansion of space doesn't mean space is expanding. It just isn't. I think he means isn't. It just means we don't know exactly how fast. Well, that could be true. But I think we've shown some reasons to be skeptical of space expanding.
Yes.
Bro Guy says, sorry, go ahead. Did you want to say something,
Yeah.
Sal?
So we'll grant that. We don't know the exact rate. Still failed the Tolman test, still failed the time dilation test 3 times over, still failed the absence, the absence of shadows test. So it's done. And then we have alternative explanations for redshifts that are very viable. And for the red, that's a big one right there. And also the microwave background radiation being local. So the Big Bang doesn't have any foundations at this point, in my opinion. You don't have to agree, but
Yeah.
I'm giving you we've read the papers here. I'm just repeating myself. Okay.
Okay, so Broke Guy says, I'm skeptical of everything, but if you intend on trying to get me to believe what you're selling, then it needs to be demonstrated that goes for religion too. Cool. Thanks for your comment, Broke Guy.
Thank you. Can I
Leo,
say something here? One reason that I'm here, I'm actually here to find out if you can persuade me that I'm wrong. I'm not here to try to persuade you. I know that sounds kind of mean, but I'm here to get criticism. I've banned a lot of people from my channel. One reason I agreed to come out, I said, I'll come out every now and then and face my critics. So, but thank you for your comment.
So Leo says, what evidence suggests it's not expanding? I asked you that twice yesterday and you never answered. Leo, I mean, to be honest, you didn't really give me a chance to answer. I actually had all of these papers prepared and ready to talk about the possible explanations for the redshift, but I almost never spoke for more than like 10 seconds without getting interrupted. So you tired me out before I even had a chance to talk about that. So, I mean, but anyway, sorry. I didn't.
She gave 5 evidences today. Okay, so I'm going to make it up to you, Rebekah. Leo did a great job yesterday because he did cut you off. It's a great strategy to prevent you from giving your evidences. I'm glad you gave this stream because you've given at least 4 that I can count against space expanding. You cited papers for redshifts, alternatives, and then the Tolman test. Well done.
Yeah, good job, Leo. You did a good job.
You did a good job, Leo. You did a good job.
I would say I don't even know if there's an expert that could do better than you, actually. I thought he did really well. Okay, so...
And Rebekah got mad at me for saying that. I thought you did a good job.
Okay, this was in response to me saying these guys who are criticizing the Big Bang are not like theists. They're like, well, some of them maybe, I don't know, but some of them are definitely atheists. But Leo said these people being theists or atheists doesn't matter to us. What matters is them being wrong about the things they say. So how do you know that they're wrong? All I was trying to point out is that they don't have the same motive that I have, right? I do want people to know God. And so, I mean, I wouldn't read a single thing about the Big Bang if I wasn't a Christian, and thinking about stuff like this. So I was just trying to show that they have no, religious agenda, but they're just trying to tell the observations. So yeah, okay, it doesn't matter if they're atheists or theists, but how about if we look at what they're saying and respond to that? Leo, again, I love how Rebekah acts like because these guys aren't creationists or atheists that somehow we're supposed to blindly believe them. No. We don't think dogmatically like you do. Actually, I don't believe all creationists. There's creationists that I don't trust what they have to say at all. So I'm not doing that. But who are you blindly believing? Because I question. I wonder if you are blindly believing what you call the scientific consensus. It seems to me that you are blindly believing them. And I would like to see evidence that you're not blindly believing them. So maybe we can talk about that. Gurr says, so just pick a few atheist scientists who reject the Big Bang and ignore all the atheist and theist scientists who accept it. We're just trying to point out the observations. I mean, if it aligns with the observations, then, I mean, that's what's important, right?
Can I point out something interesting? Yeah. At some point, we have to accept someone else's word, even scientists do. There is an element of trust and faith in something. And we're hoping we put our faith and trust in what's the truth. And so what's happening is you have a group of people that, some will align and put their faith and trust in the consensus. And then there you have the group of the dissenters, a variety of theological beliefs. And, they'll put their faith and trust in what they believe in. Because even the scientists we cited, they had to rely on the engineers that build the space probes. There's an element in faith that's in all of this. And we're just seekers like anyone else trying to sort this out. Now, I went through some trouble saying, look at my journey through school. It's just funny to hear 3.5 professors from your school disagreeing with what's being taught in my own textbooks. I mean, I can't help but notice that, guys. And when something is taboo, what happens when it's forbidden knowledge? You just become a little more curious. And it's been a joy to share what I've stumbled upon as I kind of was willing to open that box and say, wow. So, but thank you for your comment. I just wanted to share that. I like being a rebel. So maybe that's the rebellious spirit inside too. Okay.
B.S. Lewis says, can you please make the connection between Jesus and the beginning of everything? Thank you, B.S. He set us up perfectly, right? I'm sure he did this on purpose. The Bible says, in the beginning was the Word was with God, the Word was God. He was with God in the beginning. All things were made through him. Without him, nothing was made that has been made. In him was life, and that life was the light of men. The light shines in the darkness, and the darkness has not comprehended it. So, or overcome it. That's one of those Greek places where we actually don't know what it says. And I need to make a video about that probably. Okay.
But I want to someone who won the Nobel Prize.
Okay, you want to? Okay.
There's a beautiful thing. I just want John. He's the most recent Nobel Prize winner, and he quoted the Gospel of John just like you. He said, in conclusion, it may very well be said that information is the irreducible kernel from which everything else flows. Then the question why nature appears quantized is simply a consequence of the fact that information itself is quantized by necessity. It might even be fair to observe that the concept of information is very old knowledge of humanity. Witness, for example, the beginning of the gospel according to John. In the beginning was the Word. That's the most recent Nobel Prize winner. So this is why I love science.
Oh, cool.
You look and see that. Yeah.
You find people of faith doing great science. So, okay, there are still more comments, and I'm going to put up a couple from people that haven't said that I haven't put up. From Hive Science says, doesn't Redshift explain more than just the Big Bang model? I don't think so. Is there anything else that Redshift?
It depends. Oh, by the way, greetings. Thank you for the question. Redshift is a measurement. It doesn't necessarily explain things. We're actually trying to do the reverse. We're trying to explain the redshift, not say the redshift explains something. We're trying to figure out what caused it. And the Big Bang is one explanation for the redshift. And so these other stationary redshift mechanisms are a different explanation. And we're trying to see which one takes priority. Tonight, we've given evidence that it's a mechanism. The redshift mechanism is due other than relative motion. So
Hillary's email says, I think that Rebekah is giving you all the evil eye. No, I'm not giving anyone the evil eye, but it probably looked like that because I was reading the chats. But hello to Hillary's emails. I haven't greeted you lately, but I'm so glad to see you. Okay. I think I've gone through, and at least I've skipped a few comments that I originally starred, but wow, there's been like 100 comments since then, but I'm not going to try to read them all. And I want to say hi to Uncle Jesus though. Uncle Jesus, I saw your name here and I did star one of your comments, but now I can't find it.
By the way,
cool Jesus.
I got to ask,
yeah,
how did you get that handle, Uncle Jesus? Because I've used that phrase before. Jesus had nephews, really? And I wrote an article about Uncle Jesus. So.
Oh, wow. Okay. So I'm going to put the link in here, and if I'm inviting in people who have substantive scientific comments to make. And Leo, we love you to death. You had your chance last night, so I want to let somebody else on. If anybody else wants to come in and make a critique, I'm putting the link right now, so feel free to join. So we'll see if anybody comes up, and hello to Stephanie Tretton. Hello to Japheth. Japheth has had a lot of comments in the chat. Thank you. And let's see. Hopefully the link, is it there? Yeah, it's there. Okay, good. So if you want to join and talk to us, and if you have anything that you want to respond to anything we said throughout the night, if you have contradictory evidence that you want to present, please come on in. So, and thank you all for being here. Oh, good. Nick is here. I'm so glad, because Nick has been making great comments all night. So I was really hoping you would join, because it seemed like you had a lot to say. And Andrew Cumming is here too. But Andrew, I'll let you in a minute. Let's give Nick a minute to talk, a few minutes to talk to us, and then we'll let you on. Okay. Hey, Nick.
Thank you so much. Very nice to meet you. And I hope everyone can hear me. I never know where the sound is coming from, and you're gonna have 16 people in the live chat saying I'm muted, and that's just because 9 times out of 10 I'm muted, and they can always trick me into. I have more trolls, I swear to God. So, but can everyone hear me okay?
Yes.
All right. I did have a few questions, a few comments, and a few observations.
Okay.
I wanted to start though by asking, what is the claim? Because I think if the claim, oh Jesus, my soup here. If the claim is that there are some reputable scientists who think that there are alternative explanations for the data to the Big Bang, and that those alternative explanations are a static universe, I think any reasonable thinking person would be very hard-pressed to disagree with that statement. I think it is true that there are reputable scientists who believe that a static model is better, and I think you've shown that. I don't think it certainly isn't a majority. And I think that is something that you would acknowledge. In fact, that's presumably why people would have to retire after making such a claim, presumably. If the claim, however, is that a Big Bang model is not tenable, either that model is dead and the notion against that is being suppressed. The people who don't believe that are believing in miracles, and that it's an absurd notion, and most scientists already know it's absurd. I don't think that anywhere near that level of evidence has been shown today. So I guess I'm trying to figure out, because it felt like many times reasonable claims were being made. Oh, we're just trying to say that there are questions that haven't been answered, and science is denying looking at these questions, which may well be true, and I think is at least a defensible statement. And then claims Big Bang is dead in the water. It's, if you believe in it, you believe in miracles, you believe in mythology, and that's what's been said on this stream. And those two claims are very, very different claims. So I was hoping for some clarity as to what the position is here, because you can't possibly argue against both of those claims, because obviously you could switch the claims, kind of a three-card Monty, and not deliberately. But, you know, I'd like to understand what the claims are that are being made.
Can I respond first, Sal?
Yes, please.
Okay, because I'll let Sal speak for himself, but I agreed with everything that you said at the beginning, right? Like they're reputable scientists. And then I agreed with a lot. I am claiming a lot of what you said in the second thing, but not all of it. I'm not claiming that most scientists are aware that this model is a failure.
Okay.
Because for whatever reason, and there may be many reasons, you know, different reasons for different people, but they still like the model. They still believe in the model. So I very much believe that most scientists still believe in this model. But I am claiming that I don't think they have strong reasons for believing in this model.
All right, that makes sense. All right, okay. So I think I understand that now. Thank you.
Mm-hmm.
And I agree, you're two different people, by the way. So you can't expect that. Yeah.
All right. So I read the peer-reviewed papers, and then I gave my personal opinion. So hopefully you can distinguish between the papers, the actual physical evidence. I think the gamma ray burst thing is physical evidence. That's reported. That's objective. We can interpret it. I gave my interpretation. I'm not insisting anyone should have to believe me, but I had to just kind of pour out kind of my own feeling as someone who had believed in the Big Bang. And I said, you know, this is very troubling that something of this level is, why, you know, again, I have professors in my schools saying one thing and criticizing the own textbooks that are circulating in my own university. That catches my attention. And then I, you know, when I actually studied it more, I'm just like, whoa, this is a little bit upsetting. And then, so I do have an opinion. I'm not trying to say everyone should share my opinion, but I am delighted to share that there are data points of these skeptics of the Big Bang. So, you know, I claim for myself.
But what is your claim, Sal? Are you claiming that what you said is your opinion, that the Big Bang is dead in the water?
Yes.
Like that's your opinion. You're not saying that's what.
The only reason I would study it at this point is to criticize it. My interest in physics, by the way, is now in I've kind of alluded to it, is in photonics, the study of photons and its interactions with everything, including matter. And so even kind of like quasi-professionally, I want to study photonics because I'm interested in the question of mechanisms that can induce redshifts independent of relative motion. That's a very interesting scientific question. So for me, that's kind of outside of theological questions, it's kind of like quasi-professional interest. I want to study photonics because of this. So it's not just that I'm just kind of spewing my mind here. I'm actually articulating what's kind of deep in my heart, you know, a very intense scientific interest. I want, you know, if I go on for a PhD, I want to study photonics.
Well, so here's my concern with what you just said, Saul. It makes a lot of sense to me too, and I do this on my stream all the time, which is say, okay, here are the facts, and then here are the conclusions I've drawn from the facts. But the first thing is, of course, I try to make it very clear that there's a difference between the opinions, and sometimes you were going so quickly, it sounded like you were saying people like Falwell, I think was his name, are saying that the Big Bang is dead. And if you finish his abstract, he clearly does not say that. In fact, the highest bar that he will go in the abstract is that while the Big Bang is actually still a viable model, the static model, in his view, works better with the evidence as observed. And that was one reason why I felt that the abstract should be finished. Now, the abstract is just 2 or 3 pages, and if you just, no, sorry, 2 or 3 pages, 2 or 3 paragraphs, and you would read the first couple of paragraphs and then say, that's it, Big Bang is dead in the water, but the author of the paper you are citing does not make that claim, and in fact says that the theory is still viable. So the conclusions that you are drawing is actually contradicted by the very abstract
disagree
that
with
you're
that.
citing. Well, let's cite the abstract.
Okay, I even know part of it by memory. 4.4 times 10 to the minus 6 probability at Z at
I'll
6.
pull it up while you guys are talking. I'll pull it up.
Practically speaking, for
Probability
me,
of what?
when
No,
I see
stop,
when
stop.
I see
Probability of what?
figures
I
at
need to hear
that level,
probability of
that
what?
is, I
You
think
didn't
that's a
finish the
fair
probability of what?
characterization.
Probability of what, sir? I'm sorry, I'd like to hear the rest of what you
Why
said.
don't
but you
we
said
see that? I'm
said
not even
probability.
reading the abstract. I remember it because that number stood out at me.
Yeah, I heard the
4.4
I know the
times
number.
10 to the minus 6 probability. It's rejected.
Of
4.4 times 10 to the minus 6 probability is remote. I wouldn't bet
what?
a
Probability
theory
of
on
what?
those odds.
Okay, but you're making it sound like that's the probability that the Big Bang occurred, but that's not what he's saying. That's not the probability.
The
Why don't you finish
probability of
reading?
lack of time dilation is,
Yes.
if you have that high probability of lack of time dilation, that's a high probability the Big Bang is wrong. You cannot have a Big Bang if you're not establishing relative motion. And
That's not what he
that
says.
relative motion has been rejected. 4.4 times
says
10
you
to the
can.
minus 6. That's
He said you
practically
can have the
speaking
Big Bang
enough.
that way. But he says you can. If you finish reading, he says there's a way you could. He thinks it's unlikely, but yes, you could have. Yeah, but you just said can't. Can't and unlikely are 2 different.
Okay, if you want to
words.
be semantic about this, I would not personally bet. I would not expect any scientist to bet his career on a chance of 4.4 times 10 to the minus 6 probability.
No, but that
Practically
probability was
speaking,
not on the
it's
Big
refuted.
Bang.
It's dead in the water as a theory
That's
with
not
those
a
odds. Thank
probability
you.
of what, sir? You said probability. Probability of what? Probability
It's
that the
right
Big
there in
Bang.
the abstract.
Then
You
please
can
say
read
it.
it. Let's not argue. Well, why don't we read it here?
Okay, let's read it. Who wants to read it?
I can't see Rebecca.
Okay,
I
I'll
can't.
read it. I'll read it. It's on my screen. So, do I have to read all these?
Or I
equations?
can read it if.
Okay, go for it.
Okay, and there's 2 because there's another one that he wrote that I'd also like to read, where he's even less. But okay, fundamental property of an expanding universe is that any time-dependent characteristic of distant objects must appear to a scale by a factor of 1 plus z. This is called time dilation. Light curves of type 1a supernova and the duration of gamma ray bursts (GRB) are the only observations that can directly measure time dilation over a wide range of redshifts. The analysis of raw observations of 2,333 type 1a IA type supernovae light curves show that their widths relative to a standard template have a power law exponent as a function of 1 plus z of a bunch of numbers, which is consistent with no time dilation and inconsistent with standard time dilation. In addition, it is shown that the standard method for calibrating the type IA supernova light curves is flawed, which explains why this lack of time dilation has not been previously observed. Nearby observations show that the peak absolute magnitude of type 1a supernova is also consistent. Let's see. Okay, sorry, I lost my... Because here is shown the peak absolute magnitude of independent redshift. If a static universe cosmology, curvature cosmology is used to provide the distant moduli... Oh, I think I missed this. Furthermore, it is explained why the modified ACDM model provides similar results. Analysis of the duration of GRB shows that they are consistent with no time dilation and have no support for standard time dilation. All makes sense. Consequently, this paper argues for a fundamental change of the current paradigm of expanding. Okay, so wait a minute. This may not be.
It's a different paper. I'll read you
the
gamma ray. I have the gamma ray burst paper up.
All right.
But go ahead and finish it, though. Go ahead and finish this paragraph, because this is
good.
important.
Yeah, let's see. For a fundamental change of the current paradigm for expanding universe from one to a static universe, some of the major consequences of curvature cosmology are listed. So, well, this is consistent with what I said earlier, which was that he is arguing that the evidence does not support the Big Bang model. So this was not the paper to which I was referring, and both Sal and I agreed. So if we could actually hear that paper, and I think I
Sure.
did have it up in another window. So
But that is by the same author, by the way, David Crawford.
yeah, so David F. Crawford, the one I'm
okay. Characterization, you have the paper.
Here it is. Gamma rays bursts have been observed out to a very high redshift and provide, this is the one with the number. So this is the number that you were referring to. So let me read it. That are directly related to intrinsic timescales of the burst. Einstein's theory of relativity is quite definite that if the universe is expanding, then the observed duration of these measures will increase with redshift. Thus, gamma ray burst measures should show a time dilation proportional to redshift. An analysis of gamma ray burst data shows that the hypothesis of the dilation is rejected. Now, keep in mind that is the hypothesis of the dilation, not of the Big Bang, and that will be salient in just a minute once this is finished, is rejected with a probability of 4.4 times 10 to the negative 6 for redshifts out of a z equal to 6.6. Traditionally, the lack of an apparent time dilation has been explained by an inverse correlation between luminosity and time measures together with a strong luminosity selection as a function of redshift. It is shown that the inverse correlation between luminosity and some time measures is confirmed, but using concordance cosmology, strong luminosity selection cannot be achieved. So what he has said up to this point, I think you and I could agree on this, is he's saying, actually, this has been explained in the past, but the explanation is bad. It is not a correct one. And the explanation was strong luminosity. I'll get to that in a second. But so far, we're saying is now past explanations have been false. It may be possible to explain the apparent lack of time dilation. This is why that number is important. He did not say that the probability of the Big Bang was 4.4 times 10 to the negative 6. It was one specific time dilation possibility, and it is possible to explain that lack of time dilation with a combination of gamma ray burst selection, some luminosity evolution, and some measure of time evolution, but this requires a remarkable coincidence in order to produce the apparent lack of time dilation. So obviously he is not convinced, but this is far from saying that the Big Bang has been disproven to a 4.4 times 10 to the negative 6. That statistic has, in my view, been misapplied. However, the data is consistent with static cosmology in a non-expanding universe. This clearly does not say it's been refuted, only that, in his view, would have to be a remarkable coincidence for the data to operate in such a way that, given what he has here, an expanding universe is possible. That's what the entire abstract says.
But the implication is, if there is no relative motion, if the redshift does not indicate relative motion, and that's why we cited the Michael Disney paper, the Big Bang is done. That
why
was
doesn't he think
specifically pointed out. If you do not establish relative motion, there's no expanding space. It's done. He'd shown that there is 4.4 times 10 to the 6 all the way out to z equals 6.6, which is a big survey of a lot of gamma ray bursts. There's no indication of relative motion. That's the foundation of the Big Bang. If that falls, we quoted Michael Disney, who pointed that out. This is well known that if the redshift is not relative motion, the Big Bang is done. It's a done deal. That's the implicit
not according
thing.
to Crawford. Or am I missing something? That's
Sir,
not. I mean,
this is standard cosmology.
Okay,
sir.
wait.
It's
Let
assumed that you know that.
Wait, but let me jump in here, because I will defend. Sal did say that he was sharing what the paper said, but he was also sharing his opinion. His opinion was that it was dead in the water. That was not coming from the paper. That was coming from his opinion.
And my objection was He stated his opinion as if it was the author's opinion, but Crawford here clearly does not make even close to as bold a statement. That was my objection, was he said, okay, it's dead in the
I did
water.
not represent that. I said, there's a reason that we were showing the abstract right there. You can read it. You can say that Sal has a different opinion. That is so clear, and that's not fair to misrepresent me in that way.
Well,
I take exception to that,
said,
sir. You can interpret that. That's your privilege, but you can't accuse me of just misattributing it. I'm giving you have the paper. You can read it. You could form your own opinion. It should be clear enough to you what is my opinion versus what his, and what is my interpretation of what he says. Well, you can disagree with it. That's fine, but you can't insinuate I was not telling, that I was not trying to make an implicit distinction. But thank you for your comment. This is why I get so frustrated dealing with some critics. All they can do rather than deal with the data is play semantic games like this. The issue is whether the redshift indicates relative motion. I have cited good evidence from this, not just Crawford's paper. You could look at that graph and you could see the absence of time dilation. Let the scientists argue this stuff about semantic games about me. This is not about me. This is about whether the redshift indicates relative motion. If that fails, the Big Bang is done.
I believe if I said otherwise, I apologize. I didn't mean to say, and I don't think I said that it was deliberate. I was saying that the way you said it made it appear as if you were saying that that was his view. And I think that's actually on multiple papers. I think multiple papers that you've brought out, when I was listening, it very much sounded like you were saying, okay, because here's the thing. So, for example, I'd asked you repeatedly what that number was, the 4.4 times 10.
Okay.
That's irrelevant. That's irrelevant to whether the Big Bang's true or not. It's
dumpster
irrelevant.
Fire alert. Look, okay. I want to stop the argument. I think you guys have both made your points, and now you're just going to be going in circles. So
thank you very much for your time.
Nick, hey, do you have a channel? Do you want to promote anything that you do? Because I appreciate you coming on, and I'd like to know more about you.
Oh, well, that's awfully kind of you. I have a news and education program. It's called In Time. You can find it on In Time Official on YouTube. We do breaking news. We do interviews and all kinds of discussions. So anyone wants to check it out. I think most of the people in the live chat already have some idea of who I am. So that's what I do. And I sincerely appreciate the opportunity to be heard. So thank you.
Thanks for coming on. Please come on again, and talk to you later. We have Andrew waiting to come on. So let's bring him on. And hey, Andrew, how are you?
I'm doing okay. How about yourself? Good.
Did you have some critique you wanted to make or discussion you wanted to have?
Yeah, so I kind of want to ask Sal a few things because some of his language tonight seemed a bit inconsistent to me, and I just want to clarify some of those things. So I'll just stick to this one topic and hopefully not take up too much of both of your time. So at one point, Sal, you were talking about the galaxies in terms of relative motion. You kind of kept using that phrase, but at other points, you did mention the Hubble's law, the redshift distance relationship, and so I think, at least in my mind, it doesn't seem like you're making a clear distinction between relative motion of galaxies moving through space versus this expansion, because the actual idea or the evidence for expanding space is not just the redshift by itself. It's like you said, the redshift distance relationship, the fact that farther away galaxies have higher redshifts. And this shouldn't be the case if space were not expanding. Now, obviously, there are other lines of evidence for it that we could discuss at a later date. But
okay, I'll clarify. You can have a redshift distance relationship if the redshift is increased by the distance, and it's not expanding space is not the only is not the only way that you can explain the Hubble relation. You can still have a redshift distance relation without relative motion, or you can more strictly speaking, rather than using the word relative motion, without expanding space. That was the citation that involved the 2.292 megahertz or gigahertz signals in the Pioneer 6 going through the solar corona. And then there were some papers that I didn't have a chance to cite that also showed that you can have that distance relation, redshift distance relation, if the photon is passing through interstellar medium, and the more medium that it passes through, the more it gets redshifted. You can still have that Hubble relation. This will also explain, by the way, if there are variations in that interstellar medium in terms of the density, you can then resolve kind of the conflicts in trying to figure out what the Hubble constant is by various methods. So this also explains why we're getting disagreements. You don't need anything exotic to explain that. So you can still have the Hubble relation without expanding space. It's not the same. The Hubble relation does not mean necessarily expanding space. We use the Hubble relation to maybe come up with an expanding space model, but it is not beholden to only an expanding space model.
Right, and I wish you had, I was just saying I wish you had said that rather than saying relative motion, you had clarified it Hubble, the Hubble distance relationship, because as you were saying, redshift by itself does not prove expanding space. In fact, as I was saying in the side chat, I don't know at what point, but there are, like you said, many different sources of redshift than just expanding space. And so no one was originally claiming that just the redshift is evidence of expanding space.
Well, I'm really glad you're pointing that out, that redshift can have other explanations than expanding space. And that's really important,
right,
because that's why if it fails, in specifically the Tolman test, if it fails the Tolman test, that even if we suppose hypothetically that redshift indicates relative motion, expanding space has failed as the mechanism. It could be just plain old velocity.
Well, if
just
you
like
look at the Wikipedia article, it didn't say it failed, actually. If you would
it didn't say it succeeded, but that's the Wikipedia article. That's why I cited Michael Disney, that gave a more elaborate thing when he had worked on the Hubble Space Telescope. He saw the problem and he admitted this is problematic, and they had to come up with new evolutionary rescue mechanisms, what he might term as free parameters, or I call it promissory notes or epicycles. And it's gotten only worse now with the James Webb Telescope. And this testable prediction, it's going to get worse. Because if I say the Big Bang, not only is it wrong, you're going to have more epicycles, more tack-ons, and more promissory notes, more problems to fix. If you wanted funding, you'll have funding forever, because you have to keep coming up with theories to fix the problems you find. And, this could be kind of a strange thing, that you actually want to support a theory that's actually maybe fundamentally flawed, like geocentrism was.
Before we get into all that, I just want to clarify. So you are saying that you were wrong, that originally no one was claiming that redshift by itself.
No, I never claimed everyone. I never said that. That's a misattribution. If you interpret it that way, it certainly wasn't my intended meaning. So no, I'm not saying I was wrong in what I understood, sir. Everyone misspeaks. I don't believe I misspoke. I think you're misrepresenting that. If you have something substantive more than just kind of semantic games, I would welcome it. But I don't appreciate these semantic games. Why don't you try to criticize the data? Focus on the things like the gamma ray burst. Focus on the things like the problems with the supernova thing. When you gave me a citation from 2008, you said that overturned. He criticized and overturned Crawford's paper in 2018. I'm still awaiting your thing about the overturning of the lack of time dilation by Hawkins. I asked you 6 times yesterday, if this is all you can do is give me these little semantic word games to play, why don't you do something more substantive? Thank you.
Sure, I can talk about Hawkins. Hawkins got it wrong. He was using an inappropriate method. And that's why he didn't find any quasar redshift. Since then, the other independent methods have found quasar redshift.
Do you have a source for that, Andrew?
Well, sure. There's Dijon's. I can't pronounce his name. Hold on. Well, it's the paper I sent you the other day.
It didn't even mention Hawkins in that paper. It wasn't a criticism. It didn't describe a criticism of his methods.
No, it didn't directly mention Hawkins.
Okay, I'm glad you're acknowledging that, because if you're saying that refuted, if you're insinuating that it was somehow refuted and that it showed his methodology was wrong, I would be expecting then to see that his name was at least in the paper you said refuted it, and it wasn't.
I think he's saying that there's not papers criticizing him, but papers showing that, the validity.
I'm saying there was a particular method he used. He reached a particular result, and since then, using other methods, other researchers have come up with a completely different result. And that shows that his original findings weren't as conclusive as he claimed they were.
His name wasn't even mentioned in that.
That's irrelevant.
That paper you said. I think that would be relevant if you're claiming he was refuted and it's not even his name or his studies were not even mentioned there. Go ahead. You can supply it. I welcome. This is valuable that you're putting this. We had asked people that want to critique. We invite it. That's substantive. That's welcome. The word lawyering is not welcome by me. But thank you very much for that article. And if you have other criticisms. So you said the Hawkins paper. So you had the blonde in 2008. That's now on my record. I'd gladly post that, and you'll say that refutes Crawford. This will be great. To be fair, we'll let the other side be heard. And you can put the paper by Blondin, and then this other paper by, how do you pronounce his last name? Dijon or whatever. That's great. I think that's going to be fine. So, but all this word lawyering about what I said or didn't say or insinuated, that's kind of tiresome, guys. Something substance with numbers.
Because in the original Hawkins paper, he was claiming that he had found no evidence of time dilation.
It wasn't just him, sir. It was other researchers. This wasn't motivated in isolation. And it's also, so what do you think of the gamma ray burst? If I may ask you, what do you think about the gamma ray burst one? That looks pretty.
I would like to hear who else claimed that there was no time dilation in quasars specifically before we move on to that.
Well, it was, if you bothered to read the paper, there were at least one citation, maybe three, by Hawkins. Do you want to bring it up now? You want to criticize it? Or how about we move on? I'd like to thank you for giving these papers. What you're telling, everything that you have been doing has shown me that some of your citations are not as substantive, but it's the best you can give, and that's valuable to see that I think the case that I've argued today is stronger than you're claiming. Thank you.
Well, for another thing, I would also like to mention that even though we have not measured the specific factor of time dilation in quasars, there is evidence that time dilation does exist in quasars. For example, it's not as a standard as supernovae, for example, because they're obviously not events that last a specific duration of time. However, when we do look out into the cosmos, quasars from higher redshift generally have longer term variations in their spectra than nearby ones. So something is obviously going on there. So it may not be a standard set event in terms of duration. However, I have talked with researchers who have seen that these longer term variations exist in higher redshift quasars compared to nearby ones.
Well, thank you for that data point. The problem is this is an average trend. If the average trend is absent, so we could say that in general you'll lose at the casino. It doesn't mean that there won't be someone who will occasionally hit the slot machine. So that's not the issue. It's whether there is a general trend of strong Z dependence to vindicate this idea of relative motion.
You can't
measure. So I'm afraid you've not proven that. You've not shown me papers that that are explicit enough. Hawkins' paper was very, very clear. That paper you ginned up didn't really seem to support your point. But thank you for it, because if that's the best, if that's the best you have, then thank you. I'm appreciative.
Yeah, thank you, Andrew. And I would love the sources if you would send them to me. That would be great. And I'll even put them in the description of this video if you send them to me. So, do you have anything you want to promote here? Are you doing anything on your channel?
I frequent other channels, but I don't have one of my own. So not much to go off of there. I would say I love to talk more about this, of course, but I see that we're maybe.
Oh, do you have more points that you want to make?
I guess related to the things we've already talked about, but I see that that's kind of becoming a tired issue at this point.
Well, the main thing is if you're like saying counterpoints against what Sal presented, it might be helpful to see the sources right now. Like if we could pull them up or something, maybe that would help, because what I don't want it to be is just like a, yes, we have the evidence. No, we don't. Yes, we do. No, we don't. So like, if you have it, we can pull it up.
Sure. Let's see. It may take me a sec to find it.
And in the meantime, I can ask us a question from Harley's Quinn. Sal would like to know, she would like to know, or he, I don't know. Sal, how do you get a Hubble constant so high with a 6,000-year-old universe? Riddle me that, Batman.
Don't know. I believe I'm interested, and the one reason I'm interested in studying photonics is I do believe there's a possibility of variable speed of light, which, by the way, didn't originate with creationists. It began with cosmologists who were trying to defend the Big Bang, and they thought the inflation model was so bad that they felt variable speed of light would be the better fix. The thing is, though, if you have variable speed of light, that solves the distant starlight problem for young Earth creationists. So this is why I began to be a little more interested in cosmology. I said, I want to understand variable speed of light. So when I showed my equations of the d-Alembert and electromagnetic theory, this is part of that search. So short answer, I don't know yet. But if you're going to accept Big Bang's promissory notes for all the problems that they have and they're promising, I don't see why I can't have promissory notes too.
Cool.
Great question.
Like
nice to meet you. Thank you.
Okay. Andrew, do you have your source?
I know what I'm looking for. I'm just trying to load it.
We can go to another question if you like. I mean, for the comment section. Oh, by the way, this is a great chance. If you see me get kind of combative here, this is why maybe I shouldn't be on the internet, because when I confront my critics, I lose it. I get so mad at them and I want to scream at them, and it doesn't look good on me. But you can't accuse me of hiding. I'm not hiding today. You want a piece of me, I'm here, but you're going to get me not in a very polite mood if you do some of the things I've been seeing. But I'm willing to face my critics. I'm not guaranteeing I'll be nice, because I've banned a lot of people from my channel, and I said, and they accused me of saying you're not willing, you just want to be an echo chamber and not face your critics. I like fighting my critics. That's actually why I have to ban people, because I'd be on there fighting. I have so much fun fighting with people. So anyway, another question, Rebekah.
Well, I just wanted to put, I don't think the Uncle Jesus show is here anymore, but I wanted to put up his comment. He said, what does this have anything to do with proving that the God Almighty wants blood guilt cult sacrifices? Today's discussion has nothing to do with that. So Nothing.
Well,
and maybe this discussion doesn't even belong on Bread of Life channel.
No, it has a teeny
really
bit.
question
A teeny bit.
what.
No, it has a teeny bit.
Okay.
Bit. Because the Big Bang cosmology gives a chronology of 13.4, 13.2 billion, whatever, some bazillion years old. And that obviously conflicts with some of my creationist timeline. So this isn't proof that my viewpoint is correct, but it is, they're just saying you can't build your own house by burning down someone else's. Well, it's like, well, I'm kind of down in burning someone else's house down first, because at least it makes it possible to have kind of my viewpoint have maybe a better chance at succeeding. I alluded to it briefly that I like the ready-made universe, which is closer to young Earth creationism, but not quite. But so I'm speaking for myself, not for Rebekah. Her reasons for doing this are different than mine. So, by the way, I like that handle, Uncle Jesus. Oh, you're muted.
Oh, sorry. Andrew has his paper up. I'm going to pull it up now, right? Are you ready, Andrew?
Yep. If you could share my screen, please.
Yep. Can you read it for us? Because it's too small for me to read.
Sure. Yeah.
Mm-hmm.
Yeah. I have the highlighted section here. Wish I could see. Can I try to? Does that make it any better? Cool.
Yes. Thank you.
Okay. Let me highlight it again. There we go. All right. So this is, and I can link this paper afterwards. So the authors say, comparing this slope with that in equation 2 for the 13 quasars rest frame light curves, we can calculate the redshift of that particular quasar. You have the estimate right there. So they say, indeed, this value is consistent with the known redshift up here of that quasar Z equals 2.32. The same procedure can be repeated for the slower variations marked by the thick green lines in figure 1. The results are again consistent within the statistical errors, though the error bars on the slope are larger, presumably because of the noise from the fast variations as well as from other less coherent variations. Here's the part I really want to highlight. Therefore, if one can identify an oscillation mode that the particular segment of the light curve belongs to, one can readily calculate the redshift from the light curve. So this is what they were doing, calculating the quasar redshift from the available light curves. Calculate the redshift from the light curve. Note that this implies that the time dilation, which is simply a counterpart of the redshift, is included in the quasar light curves in contrast with conclusions in free. And just go down here if it's fast enough. Yes, so here reference free is from Hawkins 2010, which is the paper about claiming that no quasar time dilation could be observed. Maybe he didn't mean to make that strong of a claim, but
oh, thank you for the correction. First, that was excellent. Commendations for that. So thank you for that paper. It did say earlier, there was some calibration and selection based on supernova light curves earlier in the paper. Is that correct?
I'm not sure. I'd have to go back and look at that. I don't think there.
Can you look up SN? Can you look at the word calibrate? Can you do a search on it?
Sure. Give me a sec.
Thank you.
Okay, well, you're doing that.
This is the most substantive thing I've heard all night. Thank you.
Oh, good. Well, I want to put this back up. My favorite comment of the night, B.S. Lewis, Bread, it says right there, paragraph 2, sentence 3, God no existy. I love this. B.S. Lewis is back, so I had to put up his comment. It's he's so funny. And
sorry,
if you guys,
sorry.
Sorry, go ahead, Andrew.
Search term is calibrate. Calibrate.
Calibrate. Okay.
And for those who like blasphemous, very hilarious anti-God cartoons, please
Nope,
subscribe to B.S. Lewis. He's the best of the anti-God animators, and he has some really funny cartoons. Although I can't truly promote them because, of course, they are blasphemous, but they will give you a good laugh if you enjoy that.
If you can, sorry, share my screen one more time. I can show the keywords I'm searching here, just so everyone knows what I'm doing exactly. Let me know if it's showing up at all.
Yeah, it's showing.
Oh, what does it? Dang it, it won't show them. I'm just doing Control F, and apparently it doesn't show up when I share my screen.
Oh, okay. Like,
about that.
it's you're trying to highlight it or something for us?
Yeah, sorry about that. Apparently it
Okay.
doesn't highlight that.
No problem.
Yeah, I was searching calibrate and also SN calibration, and I got 0 results. So I don't think they were using supernova calibration curves in this. I think it was mostly quasar-like curve analyses.
Can you give me the citation again?
Sure. Yeah. Let
Please?
me link it here. Here's the PDF. Let me know if you want me to give the original link. Here, I'll give the original link.
Oh, I appreciate it. This is good. This is why I wanted this show. Finally, a contrary data point. Okay.
All right. Let me know if you have trouble there. So
okay.
Just to clarify, yeah. So all the argument I'm making is that the original Hawkins paper was it claimed to find no redshift, so no time dilation in these the quasars they sampled. These newer papers using independent methods, namely the light curves themselves, are showing that may not be the case. So I'm just saying those original results from Hawkins are not as conclusive as they were made out to be. So that is what I am arguing. And by the way, I apologize.
By the way, thank you for taking the time to find a correction of something that I said, and that's a point definitely in your favor and against me. That's great.
Okay, so
this is a good paper to look at, Rebekah. I got something that I was looking for.
I appreciate that. Thank you.
And
cool.
So thank you, sir.
Yeah. Well,
okay, I have to admit I
wasn't
wasn't totally paying attention when you guys were deep in the sciencey stuff. So can you, in 2 sentences, tell me what the conclusion is, Sal? Like, what did you gain from that? What did you understand?
This is a contrary one to the Hawkins paper that we both cited before.
Mm-hmm.
And so this is a data point responsibly. We have to say, hey, there is something of substance here. When I confronted Andrew yesterday, I asked specific explanation, and I was demanding where it actually said the word, talked about dilation. He explained himself very well. So definitely points in his favor today.
Yeah. Sorry, I had to look over my notes one more time to find some of the papers again.
Well, that's okay. Cool.
Yeah, I'll leave the rest of my time tonight. It is getting a bit late for me here, and
thanks for
I think I've said my piece.
Yeah, and I think this is a good time to wrap it up. So
yeah, that was one of the best. That was one of the best critiques tonight. So thank you, Andrew.
All right, you guys have a good rest of your night, and thank you for the stream, Rebekah.
All right, you too. Bye, Andrew. Yeah, thanks everybody for hanging with us. I'm actually surprised how many people have hung through on this stream because, it's some of it maybe is a little bit tedious. I don't know. Not as exciting and, as some of the talks we do. But anyway, thank you all for being here. And Sal, do you have any final words?
I'd like to thank you for this chance to appear. I don't interact outside of my channel very much, and maybe that's just as well. but I wanted to, it's a chance for me to say I'm willing to face my critics. I'm willing to receive substantive criticism, as I have tonight from Andrew, and I thought he availed himself well. And it's really been a joy to have a platform to talk about something that's close to my heart. And I would just say this. There is a test that, there is a prediction that Lawrence Krauss made about the Big Bang. Are we still live, Rebekah?
Yeah.
Okay, I lost the StreamYard. Oh, here it is. I found us back. I'm sorry.
Okay. Mm-hmm.
And I know you're going to cringe when I cite this. Lawrence Krauss said that at some point, 5 billion years from now, the galaxies will be receding, and that all science that we'll have will not be able to tell us that the Big Bang was real. We'll do science correctly and come to the wrong conclusions. That actually is an inherent testable prediction outside of our lifetime, but it is in principle testable. That if it happens that these galaxies recede that we have record of today, and we don't see them in the sky, 5 billion years, if they're still there, then the Big Bang is falsified. That's at least one really good testable prediction. And so there are things that we have to accept. We want to reassure ourselves that we have the answer today and not have to invoke faith in something in the future. So those who are both atheistic and believe in the Big Bang, you're placing your faith and trust in something that will be confirmed or disconfirmed 5 billion years from now. The Christian faith says you will be facing Judgment Day someday. That is a testable prediction, and that may happen sooner than 5 billion years from now. And it's sobering that when you study the Big Bang and even creationist cosmology models, it says heaven and earth will pass away. Jesus said heaven and earth will pass away. My words abide forever. And to me, that's what this has been about. So Big Bang or not, Judgment Day, according to Christian doctrine, is going to happen. That is a testable prediction. Thank you.
Cool. Well, I want to put up a few final comments. Tape Deck says, take some time to be more skeptical of your own crazy beliefs than the Big Bang. Yeah, well, I have to say some of our beliefs do sound quite crazy. I fully admit that a man dying on a cross being enough for the sins of the whole world, that does sound quite crazy. But of course, it is what I believe. And I've been living and experiencing the truth of that reality for a good majority of my life now. So it's that has been examined. Let's see. Anything else? So I'm just okay. Hunter Biden's laptops. I haven't put up one from him tonight. So let's see. You're both fundamentally dishonest people. I genuinely hope you come to feel bad about that.
Oh, thank you. Nice to see you. Another guy banned from my channel. Nice to see you again. Actually, no, that's dishonest. I despise you, Hunter. That's
This is a Christian
You're
channel.
God from my
This
channel.
is a Christian channel, Sal. This is a Christian channel, and you're a Christian. We bless you, Hunter Biden. I bless you in the name of the Lord. Good night, everyone, and see you soon.